Hello, welcome to another stream. How about that? How about that? Bet you didn't expect that shit to happen. Bet you didn't expect that. Hello, 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 NerdyBHU1, Archelesus, Tsoding TOS, Antrex, Takeo, iGood Duke, Out9, Alamander, Chistikot, Fedin69, Neutral Second, who else? Neutral Seconds, Spectre, Misfit, hello, hello, Jiang, hello, hello, welcome, 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 Dandy MacG, welcome, hello, welcome. So today is Saturday, the day of the Saturn, and that means today, according to the schedule, we're supposed to be doing game development, but since there is advent of code in place, wait a second, let me finish my sentence. Yes. Exactly. Thank you. Thank you so much for 16 months of tier 3 subscription. Thank you. Thank you. Thank you for such a generous and continuous support, and welcome to our epic assembly club. How about that? How about that? Thank you. Thank you so much. So, since there's currently an advent of code in place, what we're gonna do, we need to solve the last 25th problem of advent of code. And since it's the last one, and there's a language that, you know, is very important for making our collection complete. So for those who doesn't know, here's the context. We're solving advent of code, but there is a rule that for every problem we have to use a different language, and we've been successful so far. So you can take a look at the source code here, and you will notice that for each individual problem we are in fact using different language. So yeah, so maybe you have questions about C++ and C, and if you think these are the same languages, ask any C or C++ developer. They will tell you that they are not the same languages. Anyway, so yeah, we use 24 different languages, and I think this collection wouldn't be complete without the one and only. Not really only, there's a ton of them. Assembly. That's right. I think assembly would make that collection complete. And as far as I know, so the last problem shouldn't be that difficult, right? So it should be doable in assembly, right? Usually the advent of code 25th problem is easier to not ruin your Christmas or something like that. Right, so yeah, but I haven't read it, by the way. I haven't read it, so I know almost nothing about it. Except, okay, I got one little spoiler of 25th problem. Just one little spoiler, which may make my job a little bit easier. Just a little bit. The only thing I know about 25th problem is that its input is very small. That's the only thing I know about it. So I'm not gonna read anything, I'm gonna just straight up go into the puzzle input. And yeah, so it is true. You literally have two numbers. So because of that, I think we can cut on actually, you know, reading files and shit like that. So we can literally hard code this input into the program. And yeah, it's, I mean, come on, like I've been using different languages that I don't even know about for like 24 days, right? So do I deserve a little bit of help? Like, this is the only thing I know about this problem. Seriously, this is the only thing I know about it. Come on. Need to read command line arguments. Fine, we're gonna read it from file, sure. Okay. God fucking damn it. We're gonna read it from file. Get ready for the 10-hour stream. So we don't do a programming language rating here. If you're here for my opinion about programming language, or what's the language I should learn next, you're missing the point, and I think you're watching wrong channel. I'm really sorry to tell you that. So you're kind of missing the whole point. So, yeah. And so the assembly that we're going to use today is going to be x86-64 assembly. It's not going to be AT&T dialect. This dialect can die in the ditch. Thank you very much. I'm going to use Intel dialect. Okay, the one and only Intel dialect. So, and the specific implementation of assembly we're gonna use is NASM. Yeah, because I'm the most familiar with that specific implementation. Yeah. Get certified nutrition and personal training certification. Yes, that's what we're gonna use today. Not really. I'm joking. It's actually located in nasm.us. In nasm.us. Yeah, we're gonna use this one. We're gonna write a program for Linux, and we're gonna use Linux specific syscalls. I'm not gonna use libc. I already tried to write assembly programs and link with libc. That was a huge pain in the ass. I don't want to do that anymore. So we're gonna use directly, you know, Linux syscalls. What else? I guess that's pretty much it. So we can jump right into all of that. Not a real x86 assembly with BIOS interrupts. God damn it. I mean, whatever. Okay. Are you guys ready? There we go. Team Yukos. Zozin AOC. I think I did a little bit of a cleanup off screen. Git merge origin master. By the way, I forgot everything about programming and assembly. So yeah, you'll have to actually backseat me and help me with all of that. So it's gonna be 25 ASM, right? 25 ASM, and let's start with writing hello world. Right, let's start writing hello world. Okay, hello world. So we're gonna call it main ASM. There you go. And oh, I even automatically use NASM NASM mode, which is, yeah, I already it's just I already programmed in NASM. All right, so I guess you have to like do like a segments or shit like that. Yeah, segment like text, but I don't quite remember. I also remember that you have to declare like a global entry point, and I think this is how you do that. And yeah, so essentially your program will start like @_start, and then section. Yeah, it's a section. Thank you so much. Yeah, because I forgot pretty much everything, right? So it's gonna be that and section text, and let's actually write something that is simpler than hello world. Just an empty program that does nothing except calls the exit syscall of Linux. Right, yeah, exit 0. So this is the simplest program, simplest Linux program that you can ever write. All right, so I need sys Linux x64 syscalls. So there's a lot of different tables that you can use. Hopefully I'm not banned on that website. Yeah, there we go. So this is x8664. Right, sys exit. So the number of the exit syscall is 60. Right. So, and I don't remember. Yeah, you have to put it in rex. Yeah, you have to put it in rex. So I remember also that you can use a macro language of NASM. Banned on website with ASM instructions. Yeah, I mean, at some point there was like some sort of a Cloudflare situation where majority of the Russian IP addresses were banned. And when I went to this website, it would expose my IP and shit like that. So I remember it just happened to me one time. Why would you be banned? Because I'm Russian. So, all right. Imagine being Russian in 2020. Holy fuck. So we're gonna do something like this. It's gonna be sys exit, right? Yeah. And this is how we're gonna go about that. We're gonna move sys exit here. I don't know how to write something like that in AT&T. I'm pretty sure to write it in TAT, essentially what you have to do is something like this. I'm pretty sure. Like you have to add shit ton of like percents, like here and here, And this is like a, you know, the regular AT&T syntax. Like I never actually programmed in, you know, assembly, AT&T assembly, so I don't really know, but this is how it looks like to me. All right. So just shit ton of percents for no reason whatsoever. Okay. Now, I'm just joking, of course. It's just like I didn't get used to AT&T syntax. Okay, so that's the reason why I'm using it. It's not because it's objectively worse or better or anything like that, right? So I'm pretty sure you can get used to whatever, you know, to whatever people throw at you. But it's just like I never bothered to learn it, so and it confuses my brain. So I'm just not smart enough to do that. Okay, so syscall also accepts an argument, and the argument it accepts is the exit code, and you put it into RDI, right? So you have to put RDI, and let's actually put 69, right? We're gonna put exit code 69, and after that we have to execute syscall. That should be it. So this is the simplest you know, Linux program you can ever write. Hey Watson Plus, welcome to the stream. Welcome. How are you doing, buddy? Really glad to see you. So, use syscalls. Why? I already have a thing here. Chromium OS docs. I mean, Chromium OS is also based on Linux, if I remember correctly. But I mean, it's the same thing, isn't it? It's the same thing. Why do I have to use something else? Well, I mean, thank you. But I'm not using Chromium OS. That's the thing. I'm using Linux. So I'm not sure if it's the correct table for me. I'm sorry on that. Alright, so let's actually try to build all of this shit. I'm gonna create a make file. And I don't quite remember. I think, yeah, you have to do something like main.o, main.asm, right? Nasm, and you just do asm, right? So, and that will create you the object file. And that didn't work. Not supported in 16 mode. Oh, okay. I think this is one of the things you can do. Yeah. This is one of the things you can do. Ah, holy fuck. I think, yeah, what essentially this thing does, it doesn't generate you ELF by default. It literally generates you like a raw assembly file. That's fun. Yeah. To be fair, like, this is actually a pretty good example of how overbloated ELF is. Right, so without any ELF bullshit, the program that does nothing on Linux and just calls the exit code will be 12 bytes. 12 bytes? Like, one instruction? No, we can count instructions here. So you literally have 3 instructions. This is 3 instructions. Right, first instruction is going to be adding a syscall to Rax, and then adding parameter to RDI, and then calling syscall, and syscall is a separate instruction. Sysc is bloat, yeah, I guess. But who uses Sysc anyway? So the modern processes use RISC under the hood, as far as I know, anyway. Okay, so I think what we have to do is to do something like format ELF64, if I remember correctly. I remember things from, yeah, there we go. Now we generated ELF64. Filth. It's like Florf, but it's Felf. Felfs. Can we get some Felfs in the chat? I filth on the floor. Anyway. So, and this is not enough. After that, you have to link this shit, right? So you have to use LDO main.o, and after the linkage, you get an executable file, which is 4.7 kilobytes. 4.7 kilobytes to store 12 bytes of pure instructions. How about that? Strip it. I mean, I'm pretty sure you won't be able to strip it. Like, there's nothing there. Anyway, it's like it's. I mean, it's 4.3 now, or whatever. Yeah, doesn't really do much. And we can take a look at this file and see what's going on there. So it's statically linked, by the way. It doesn't even depend on libc. How about that? Doesn't even depend on libc. And if we take a look at LDD, and we can see that it's not a dynamic executable. It is not a dynamic executable. And now if I try to run this shit, it's exited abnormally with the code 69. Do you recognize that? Do you recognize that? We explicitly said, please exit Mr. Program with a code 69, and it did it very nicely, very nicely. There we go. So yeah, we can actually make like 0 here, and let's actually recompile it every time we want to run it. And there we go. As you can see, compilation finished. And did it run it? I don't remember if it ran it. Yeah, it's supposed to run it and run it. There we go. So this is the smallest and simplest program you can write for Linux. And the next thing we need to do, we need to write a hello world. Right. So to write hello world, we will need to call the write syscall. So write syscall accepts file descriptor to which you're going to write things. In our case, it's going to be standard output, and as far as I know, standard output is what? 1. I think it's 1. 0 is a standard input, standard output is 1, and standard error is 2. Okay, then it accepts the pointer to the buffer from which it's gonna, read the symbols to write them into the file, and the size of that buffer. So we need to allocate that buffer somewhere. We usually allocate it in section data, right? This is usually where we put all of that, and we're gonna have a hello buffer, right? So this is a hello buffer. What kind of idiot plays music at full volume in their car? It's not me. I don't even own a car, old man. I'm sorry. I don't even know how to drive a car. Believe it or not, I'm 30 years old. I don't know how to drive a car. But yeah, I have a problem with noisy neighbors all the time here too. So fucking annoying. So here's the hello world, and we should not forget to print a new line. But as far as I know, escaping is not gonna work in NASM. Maybe it will. I don't quite remember. Yeah. 29. You're all 29 here? Why are you such a zoomer soul here? But anyway, so here's the buffer. So here's the hello buffer, and we're gonna have hello size. Right, hello size. And I remember you can compute the size of the buffer by doing something like, oh, by the way, you have to do something like db. Yeah. NASM db string. I think that's how we do that. Using db to declare a string in assembly in NASM. Yeah, this is literally how you can do that. So it just declares like a byte for this entire thing. It doesn't support Unicode. Unfortunately, string literals in NASM do not support Unicode properly. I'm really sorry about that. Maybe they do, by the way. Maybe they do. If you like put a Unicode shit in here, will it work? Let's actually check it out. Yeah, let's actually check it out. Maybe it will work. So yeah. And then you can calculate the size of the buffer. NASM size of buffer, something through a $sign, if I remember correctly. So essentially, like $sign indicates the current address. Where is the? Oh, I'm in Russian mode. Yeah, current address, and then you can subtract the address of this buffer, and you essentially get the length of this buffer, if I understand correctly. And I think you also have to do something like dw to store this size. But in our case, it's going to be, yeah, the size of the racks is essentially 8, so we can do, I don't remember, dq is what? We need the size. $sign, what does dollar means in x86 assembly? Stack Overflow also has a 0 terminator at the end of the string. Thank you, Captain. Very cool. I really appreciate you. Current, yeah, so it actually means current address. Alrighty. So NASM DB DW DQ. I want to have some sort of a table where I could just have the data types, like DB is 1 byte, DW 2 bytes, DD 4 bytes. Is there something like that? Is there a is there like a table where I can check it out? Is there like a table? DB, no. Types, stored variable types. It's really strange. Pseudo instructions. Here they are. Here they are. Okay. Declaring initialized data. Cool. Where is the association between them? Okay, so I would really prefer if there was like an association or like the name, size, name, size, name, size, but this is also okay. So 2, 1, 2, 4, 8, I suppose. This is supposed to mean 8, like quadra, right? So this is a word. Double word is 4, quadra word is going to be 8. So that means I'm going to put DQ here. Cool. I think we defined everything, and if I try to recompile, it still compiles, and I can put some bullshit here to... Yeah, there we go, it doesn't compile. Cool. Now, we need to learn how to work with the write syscall. So the value of the write syscall is 1, as far as I can tell, so we're going to do define sys write, so here is 1. And move rex sys write. Okay, this is the first argument. The second well, I mean, it's just the name. The first argument is actually fd, so we have to move rdi. And let's actually create a macro for this thing as well. I really like to create these macros. So std out is gonna be 1. So we can also create things for example, for std in. Just in case, and maybe something like for std error, which is going to be 2. We're probably never going to use them, but I just want to have them just in case. So this is going to be std out. The next argument is rsi, and this is going to be the buffer. I don't remember how to take the address of the buffer. I think you have to do something like this, but I'm not going to do it right now. I'm going to just put it like that. I think the assembly will tell me that I'm doing something wrong. And RDX is supposed to be the size of the buffer, so it's going to be RDX, and it's going to be hello size. There we go, there we go. So if I try to compile that, it's not supposed to compile. Oh, I think it compiled and it actually executed, but it started to print the garbage after all of that. Oh yeah, this is actually very interesting. Huh. First of all, I need to reorganize things like that. So here is the write syscall, here is the exit syscall, and this is how I have to do that. So this is the first thing. Second thing, null terminator. I don't think we need a null terminator. Guys, think for a second. Why the fuck syscall accepts count? Just pause and think for a second. Why the fuck syscall accepts count? I see people talking about null terminator in chat like for 5 times already. Can you tell me, if I need to have a null terminator, why the fuck do I pass count? Just think for a second. Just think for a second, please. Please. Come on. Don't disappoint me. Don't fucking disappoint me. Okay. All right. You can also take a look at the documentation of a write syscall. This is not documentation of a write syscall. Yeah. Essentially, yeah, here's the buffer, and this is what you do. So here's the buffer. Yeah. Cool. So it could be something with this kind of stuff. Hello buffer, and it could be yeah, that's actually a good point. It could be because it's a pointer, so maybe this is exactly what we have to do here. Yeah, and let's put it back, and as you can see, it's correct answer. Finally, somebody was careful, tried to understand the situation, and said the thing that is related to the situation. I really appreciate that. Okay, so /n doesn't really represent a new line, so we'll have to do something like that instead. And there we go, here's the new line. And here's our hello world. And by the way, as you can see, Nazem supports Unicode. Nazem supports Unicode. Why aren't you using null pointers in your mesh shaders? Yeah, that's a good question, thank you. By the way, so I think an alternative of loading a thing from an address would be to use layer. Would it not? Will it work as well? Invalid combination. I think it's not the same. Yeah, I keep forgetting what's layer. Yeah, I see people using it, but I keep forgetting like what it means, and yeah. Anyway, so this is a hello world. This is a hello world for RSI. Okay. Cool. So by default, this is an address, and this is how you dereference an address. Essentially, I suppose this is how you dereference an address. Cool. Do we want to parse layer? Yes. Is it an instruction in assembly? Or are you debating me? Is it literal an instruction? Nah, you're debating. Is a virtual ASM created? Yeah. Alright, so so we need to parse the command line arguments. Right, we need to parse the command line arguments. So what's funny is that command line arguments in C specifically, in C, right, they're passed like that, right? So it's two arguments. So the call convention in 64-bit Linux is that the arguments are passed through these registers. Actually, they're passed through these registers, specifically integer arguments, up until R9. The floating point arguments are passed through the floating point registers. So that means the RGC and RGV are located initially in RAX and RDI. This is what I remember, at least from you know, Linux conventions and stuff like that. So theoretically, if we take a look, like at this particular point, if we take a look at RAX and RDI, RAX is going to contain the amount of command line arguments, and RDI is going to contain a pointer to the arguments, right? And then we'll probably be able to access them, if you know what I mean. But what would be the easiest way to actually inspect the registers? What do you guys think will be the easiest way? I think it would be easier to do through a GDB, but I think if I try to GDB this thing, it's not gonna go really well, because you still need debug information. Maybe even the environment pointer. Yeah, I think the environment pointer is going to be located in RSI. We can even inspect all of that and just see. All right, so let me see. Maybe move the write syscall to its own label. Why? Okay, so if I try to break on start, right, and I run this thing and I do TUI enable, it's not going to really work. So the thing we'll have to do, TUI, I don't remember, layout ASM. Yeah, there we go. Yeah. So, and I think I also can enable registers. Yeah. And as you can see, RAX does not contain anything. Like, RAX is literally just 0. So we don't really have anything, which is quite interesting. Rax, RBX, RSI, it's all new. It's all new. I retrieved with the C runtime, which you don't have. Well, how C runtime is doing that? It's just I don't know where to start to answer that. Exactly, maybe they're on the stack. Like you say, like, oh, you cannot do that. Runtime, C runtime can do that. That means I can do that as well. Why are you wording it like that? I mean, okay, it's like, let's re-implement the part of the C runtime that does that. Sure, whatever. It's not an impossible task. Holy fuck. RSP contains... Oh, okay, thank you so much. So, how do you inspect the registers, though? Okay, GDB inspect registers. Info registers, okay. Info registers, and let's take a look. I think you have to do something like RSP. No, I cannot go up for some reason. Okay, I have to use that. Okay, and the other one, RSP contains RSP8. Huh. Wait a second. Well, okay, can I print this address? I think I have to do it like manually. So this is an address, and if I cast it to the pointer of integer and then I try to dereference it, it contains 1. Okay, so +8. Huh. And if we take a look at this thing, okay, so this is that +8. Then we can interpret that as, I suppose, char pointer, and we'll try to dereference that. Maybe we can even do something like this. Okay, but we'll have to actually, I think, do it like that and dereference it once. There we go. Okay, we found it. Jiang, thank you so much. Thank you. That's actually pretty cool. Yeah, magic. Well, it is in fact magic. So that means they are allocated on the stack. So RSP, yeah, they're literally pushed in the stack because RSP is. Okay, maybe you will only have 24. What do you mean? I mean, I can actually. I don't really have to do all of that. I can just hard code these two numbers and I can just hard code these two numbers to the executable, and yeah, but you guys want me to implement like a proper thing, so anyway. All right, so let's go and do that, I suppose. Let's go and do that. So I probably need some sort of a function that will print a multiminated string, right? So I definitely need something that prints multiminated string, because right now you cannot just put that string into this syscall, because it doesn't know anything about multimination, right? So let's implement something like puts. Let's implement puts. So how we're gonna do that? To implement puts, we also need strlen, right? Aids, but this time it is libc in assembly. Well, yeah, I'm actually literally re-implementing libc in assembly. Okay. All right, we need strlen. How are we gonna implement the strlen? Are we gonna follow the Linux conventions? and we're gonna accept the pointer in rex, right? Rex. So we can now, yeah, I'm gonna initialize the result in RBX. First argument goes into RDI. You sure about that? You sure about that? Oh yes, it does go to RDI. Okay, so that means it's gonna be RDI then. That means I can easily initialize Rex to 0, and it's gonna be automatically the result. And now we can take a look at RDI. Right, how can I take a single byte at RDI? Right, so RDI contains an address. Yeah, one of the things I want to do now, I'm gonna move RDI RSP plus 8. Right, RSP plus 8. We're moving it to RDI, and then I call strlen, and then we're gonna inspect all of that in the debugger. So I move this thing into RDI and I call strlen, and then we're gonna try to do this stuff. We're gonna try to do this stuff. So so in RDI, can I move this thing into a single like byte? So if I do this like that, so we have RBX. Can I do just BL? Will that actually move a single byte to there? Well, I think it will actually move a single byte there, and then we can compare it to 0. So I think doesn't make T because he doesn't need to Google Absolution. God damn it. Okay, so I think to compare it to 0, I think we have to do something like this, right? And then we have JZ, right? And that will like repeat this kind of thing. Okay, so asm test instruction. I forgot what test instruction means. So let's take a look. I'm sure there's tons of some. Okay, instruction performs a bitwise AND on 2 operands. The flag SF ZF. We only care about ZF. I modify it while the result discarded. Okay. Yeah. Conditional jump. Set ZF to 1 if. Doesn't move set the flags? I have no idea. Probably it does set the flag. We can take it out. Check it out. Asm move. I think I'm paying too much attention to the chat because people just saying random stuff that confuses me. It definitely doesn't set anything. I don't have to do that. So if it's a 0, we need to keep moving. I'm not thinking about instructions right now, I'm thinking how to organize the loop, okay? I'm thinking how to organize the loop. If it's equal to 0, that means we have to break out of the loop. And yeah, this is what we're gonna do here. I'm gonna put AND here, JNZ, and this is gonna be begin, right? Otherwise, we do GMP begin. So I think this is the easiest way to approach all of that. Right? It's the easiest way to approach all of that. Yeah. So strlen, we initialize it like that. And by the way, here we have to do something like into increment rex. Right? We extract the. In Russian language, we have a letter that looks like this. I just realized that. Okay. Yeah, we're moving the byte, we're testing the byte. If it's 0, we go to the end and instantly return. Then if we don't, we increment the racks and jump begin to the begin. But this is not enough, by the way. We also have to increment RDI. I forgot to switch from Russian. God fucking damn it. RDI. So I'm also incrementing RDI. And that's the implementation of strlen, believe it or not, boys and girls. That's the whole implementation, I think. So the result is automatically expected to be in racks, right? The result is usually returned in racks, if I remember correctly. To be fair, I might actually comment it out, and we can have a test. String. Let's actually put it as s. Hello, and it ends with 0, and this should be equal to 5. This should be equal to 5. So, and what we're gonna do here is we're gonna move RDI, what was that? RDI S, and then call strlen. So, and then racks is going to contain the size of this string. Alright, so let me try to rebuild all of that and we'll see how it goes. We'll see how it goes. We successfully rebuild it. And let me go to GDB main. There we go. And I'm gonna run. Yeah, I'm gonna break at start and I'm gonna just run it. And it's gonna be layout awesome and layout. Maybe I can just check the registers myself. Okay, move absolute, and we set this thing to RDI, layout registers. Cool. So I'm making the first step, and I don't see RDI here. Oh, you are supposed to use an I, not N. Nice debugger, by the way. Thank you so much. Nice debugger. Break start. Run. Layout awesome. Layout registers. NI. You have to step a single instruction. I keep forgetting about that. So can I also take this thing and just print what's there? I think the way I have to treat that is going to be char, and there we go. So it says hello. We know that hello is located there. Now let's step into the instruction and let's see how it's gonna go. I might as well actually, you know, keep displaying that thing. Or maybe not. I'll see. We are initializing racks. And then we move a single byte into that. So info register BL. And BL contains 68, and I think it is ASCII of hello. If I take a look at ASCII, 68. It's not that one. Yeah, it's H. It's actually H. Right, it's actually H, and we test it, and then we increment racks, and then we jump back. And look at racks, it's gonna keep incrementing until we reach the end. So it has to be 5. Once we add 5, it actually returns, and we can clearly see that it contains 5. Nice. It contains 5. How about that? Isn't that epic? Isn't that epic? I think it's pretty goddamn epic, bro. Cool. We have strlen. We implemented a small bit of libc standard library. So puts. What about puts? In here, we're gonna accept RDI and RSI. I think we're gonna only accept RDI. That's for sure. Yeah, we accept a string through RDI, and that means we actually need to save RSI somewhere. Can I push RSI on the stack? I think I can. So I'm pushing RSI on the stack. Then I'm calling strlen. And now racks contains the size, right? And the size has to be moved to RDX. Right, we're moving from Rex to RDX. Cool, from Rex to RDX. Now we have to initialize Rex as syswrite, then RDI has to be standard output. The RSI, wait a second. It's located in RDI. I keep forgetting the conventions, by the way. I keep forgetting the conventions. So I need to put them somewhere here. So this is the integer conventions. Yeah, integer conventions, and we can do something like query replace tab space. Let's put it like that. So this is a convention. So RDI is the first one. We push RDI. And okay, RDX is that. RDI is std out. And RSI. I wonder if this is how it works. I wonder if this is how it works. And after that, of course, we have to do a syscall to actually execute that syscall. So this is going to be puts, I think. This is literally going to be puts because it just gets the size of the string it got from RDI and then calls the syscall. Right, so puts is implemented on top of strlen, and now we should be able to work with null terminated strings. Right, so we save RDI on the stack. We call strlen, so RDI already scuffed, and this is, by the way, the reason why we pushed it on the stack, and Rex contains the size. RDX becomes a Rex because it has to contain the size. Rex becomes the syscall, RDI std out, and RSI is the pointer to the buffer, and we save the pointer to the buffer to the stack, so we popped it out. Hopefully that will compile. And another interesting thing, look, we moved string, our hello, null terminated hello, null terminated hello, right? We put it to RDI and we call strlen, and if we replace it to puts, it will just print that null terminated string on the console. Hopefully, we'll see. So it all compiles, and first try. Well, it also printed this thing, as you can see, but it's not really needed. It's not really needed anymore, so I can just comment it out. So there we go. We now have puts. But what's interesting about puts is that it doesn't do a new line. But we can easily implement something like new line db. I think like 10, right? I think like 10 is going to be new line. And then we can take this entire thing, copy paste it one more time. Right, this is going to be that new line, and the size of new line is 1. We know that for sure. So puts will also print a new line afterwards for you. So we don't even need to do anything. You see? So that's actually pretty convenient. It automatically prints a new line for you. So we have like a proper puts here. Nice, and yeah, that's pretty cool. So next, I'm gonna remove that, and we don't need hello world here anymore. I think it's kind of dumb. We don't even need like to store the sizes of the buffers, because we can essentially like work with null terminated strings from now on. And now we can try to print a first command line argument, right? So RDI. So it's located in RSP, so we can do something like RSP plus 8. Right, here's RSP plus 8, and this contains a pointer. But it's a pointer to a pointer, right? It's a pointer to a pointer, so how do I dereference a pointer? I think I can do it like that, RSI, and then maybe RDI RSI, probably. And then just do call puts, and will that print the path to the program? Will that print the path to the program? Let's actually find out. It didn't complain, and it's segfaulted. Okay, so this is not how we do that. So that's very interesting. We can, is already deref. You think about that? You think it is? Wait a second, Jiang. Are they located in memory like so? RGC, like this is the memory. Then RGV 0, 0, RGV. No, there could not be located like that. If it's already deref, how is... Ah, I see what you mean. I see. Just a second. Yes, I see what you mean. I'm an idiot. Okay, so that should be enough. That should be enough. No. First try, motherfucker. Look at that. Look at that. Look at that. Look at that. Oh shit. Boomer was too slow. Yeah, so main. We got a main. Now we need to iterate through all of these motherfuckers and print all of the command line arguments. How about that? How about that? Yezu. So let's see how we can do that. So we can keep all of that in RDI, I think. Maybe we can. By the way, can you do something like this, like without dereferencing anything? Invalid register set. Well, technically, you can just do something like this and then add RDI 8. You don't necessarily have to do it like that, right? It's just, yeah, it's just for dereferencing purposes. You can use Leo. I don't know how to use Leo. All right, but I can learn it on the stream, so maybe that's gonna be the thing. Anyways, so we have a RAX, and RSP should contain the amount of arguments. Replace. Is that a command? Holy shit, we have like a person who gives me orders to do things. Okay, so RDI, and then we're gonna have that thing. So, and I think I'm gonna keep it like that, and then I'll have to do add RDI 8. So, now, so we have everything ready, I think. We have everything ready, so I want to test RAX with the RAX. And if it's JZ, so we're gonna go to the end. Right, it's gonna go to the end, and below here we're gonna go jump to the begin, where we're gonna test this shit yet again. Right, we're gonna test this shit again. And here's my loop. Here is my loop. So we test it here, and then yeah. Okay, so what do we essentially do? RDI already contains puts, right? Does it fuck it up? Does it fuck it up? I feel like it could potentially fuck it up, so we're gonna push RDI on the stack. And then we're going to call puts, right? We're gonna go call puts, then we're gonna pop RDI from the stack, and we're gonna add 8 to RDI, and we're gonna decrement RAX. Decrement RAX. So I think that's going to be our loop that iterates through all of the command line arguments, and yeah, I think that's a good way of doing that. And let's see, bar buzz, and it didn't do anything. That's very interesting. How many times did it actually iterate? That's a good question. How many times? So let me try to do the following thing. So this is the begin and end. I'm gonna remove all of that except maybe that, right? And I want to just do move RDI s call puts, right? I'm gonna call puts, and let me see what's gonna happen. It only printed it once, which is kind of worrying because I provided more arguments here, right? So where's the main? Where's the main? Okay, here it is. RSP contains the amount of arguments, so I move it to RAX. Oh, I think like puts also fucks up. Yeah, I forgot that puts also fucks up rex. So I have to be super careful with this kind of shit. All right, so we have to do push RDI and push rex. Then we're gonna do puts. To be fair, I think these functions have to do that for you. I think they have to do that for you automatically. Yeah, I think it's their responsibility to do that like this, but I'm not sure. So then we can pop rex. I'm gonna just do it like that for now, and then we'll see if it's gonna fuck up too much. And okay, so that's pretty cool. That's pretty cool. At least it actually went as many times as we have these arguments here. And if I provide only one here, it actually... Okay, it prints the garbage, but apart from the garbage, it is okay. So I think there's something wrong with dereferencing here. I see. So we're gonna store that in RSI, I think. So where is the convention? So RSI is the second one. RSI is the second one. And this is gonna be like this. So here's the RSI. We move this thing to RSP, and then we increment it by 1. All right. So then we do rex. So this entire shit, we push RSI, right? Pop RSI and add RSI 8. But what's funny is that before calling puts, we have to move RDI and dereference RSI. That's how we're gonna go about that. And if we recompile that, it compiles way too fast. Full bar plus motherfucker! Who's the god cooler here? We are iterating through command line arguments. All right. We're iterating through command line arguments, bro. And we can also increment rex to exclude. Exclude that other shit. Okay, so it's also segfaulted, which is... Oh yeah, I have to decrement it. Yes, that's what I need to do. I have to decrement it. And maybe... Yeah, I have to decrement it and actually add like 16 here. Yeah, I'll have to add 16. And... Wait, what? How do I exclude the program? How do I exclude the program? Obviously, I'm decrementing rex every time I do this thing. So that means I have to definitely decrement rex. But I also increase in RSI. So that means I have to do that at least twice. 8 plus 8 is 16 if I remember correctly, right? So 8 plus 8 is 16, and I think it worked. And is it not 16? Wait a second. It is 16. I'm a Pepega? Okay, I'm not Pepega. I don't know why it didn't work first time. Maybe I just forgot to do something, but there we go. We're also now excluding the program name, and we just have these things. Right, we just have these things, and we can have input, sample txt, and there we go. We have everything we ever wanted in our entire life. So, yeah, it's a little bit cold in here, right? So I would like to maybe make a cup of tea, but we'll see. All right, so I don't remember what's the convention in assembly. I think you're supposed to just push the state of the registers on the stack and then pop it out. Is that the convention here? I think it is. I think you have to do it like that, right? So you won't have to do that like outside. Oh, by the way, assembly is actually is actually super dangerous to write because you can easily screw up things. So I'm gonna go ahead and make as commits as frequent as possible, right? So that's gonna be my approach. I'm gonna make very frequent commits. So I'll need to git ignore everything here. So we're gonna git ignore main, and we'll also git ignore O, and I think that's the only things we'll need to git ignore. 25. Args parsing. Yes, args parsing. 1 hour and 2 minutes. I mean, on some languages, it actually took more time for me to parse command line arguments. So, push A, yeah, this is what I was thinking about. Thank you. Push A and pop A. All registers in the same order. You don't want a count register that, yeah. Push A and pop A doesn't exist on x86. That's, but what does exist on x86, x64, I mean? All right. So, because I want to push all of the registers if it doesn't exist. So what exists? Nothing. Push them manually. Oh, okay. Well, I mean, it makes sense. I can try to do that. So I can literally just try to do push A and pop A. Instruction not. Fuck. Ah! It is true, actually. It's not supported. So, yeah. Push Rex. Push RBX. Push RDA. Okay, Rex, RBX, RDI. And I think that's it. I think that's the only things I needed here, right? And what's funny is that I'll have to do them in reversed order. But can your Vim do that, bruh? How about that? Can your Vim do that? You can literally select a region and you can reverse the lines. So this is strlen. What about pps? What about pps? Okay, so we'll already push. Oh, that's kind of funny. We'll already push RDI, but and we'll also pop it. X64 push A. Really, is there's nothing we can do about that? How to save the register in X64 interrupt services? Really? Learning from existing, for example. In fact, manually pushing the regs is the only way. Are you fucking serious? It's so bad. Holy fuck. I mean, we can probably write a macro, okay? We can probably write a macro that basically does that for us, like all of them. What do you guys think? Like we can probably implement, define like push all and pop all, and this is going to be just a section of these instructions like all the time. I think it's a good approach. So we can automate the boring things with macros. But how do you write another macros? Maybe just push registers that you use as a temporary variables. Where do I start to answer this question? Okay, let's put it this way. I'm so lazy and dumb that I cannot and do not want to keep track of the registers I'm using. I know that you are smart enough that you're interested in doing this like very boring thing as tracking the registers that you're using. I'm not that smart and really interested in this kind of stuff. You see what I mean? You see what I mean? I'd rather have like a single thing that works for everything. I'm that lazy. I'm sorry. I'm that lazy. I don't like to do work. So actually, push pop Rex will end up discarding your return value. Fuck. All right. Yeah, we'll have to do that a little bit careful. Okay. Alright, so that is actually complicated than I thought. Maybe I'm gonna just do it like the following way. I'm gonna assume that any function call may fuck up my registers. And I guess I'll have to do that work, unfortunately. Unfortunately, I have to do that work. Yeah, it's too sad. It's too sad. Full bar. Okay. So I'm gonna just assume that they can fuck up your shit. Alright. I mean, you can still save, restore, RBX and write. Yeah. Okay. Okay. So what else do we have here? So we don't really need that thing. Let's introduce input file. Right. Let's introduce input file, and it's going to be just db input file, and this is going to be null terminated. So we're going to introduce the following thing, which is called solve file. Can you imagine that Jack is only a student when he sounds like he's working with ASM for 50 years? Well, he kind of is. He's been writing an operating system. Alright. Okay, so instead of doing puts, the thing we'll have to do here is call solve file, right? We're gonna do call solve file. So, and we pass it through RDI, right? We pass it through RDI, and essentially what we're gonna do, I'm gonna push RDI, I'm gonna set RDI, and I'm gonna move RDI to what? Input file. So here's that thing, and then I'm gonna call puts, then I pop RDI, and I call puts yet again. So essentially what this entire thing does is yeah, it just prints input file space and then the name of the file. God damn it! I need puts without the new line. Okay, here's the idea. Here's the idea. What about having print instead of puts? Right, so we're gonna call it like this. Puts print. Actually, no. Println. This is a println. And we're gonna have a separate print. Print. Like this. So what's interesting about this separate print is that it's gonna look like this. And yeah. So there's that, and then we're gonna do red. So here is the println. We need a new line. It's gonna be this. Maybe I'm gonna even call it NL. Yeah, input file NL. Okay, so here is the print. It just prints the RDI. Cool. Now we're gonna have println. All right. So RDI, push RDI, call print. Nah, we don't need to do that. I think we can just call print, then move RDI NL, call print again, and just return. So this is a println. Okay, so this thing just prints whatever you want, like null terminated string. Println does the same thing, but also prints the new line, right? And when you solve the file, what essentially you're doing, you're printing the input file, but printlning the rest of the thing. And if you try to compile this entire stuff, it compiles, and there you go. You have input file full, input file bar. Damn. Who's the god cooler here? So, and then next, you can literally have things like sample.txt, input.txt, and everything looks okay. Everything looks okay. Naizu. Yeah. and we like literally starting to have like a standard library. Like we already have in a standard library strlen, print, and println, and we can rely on these functions. We can already rely on these functions, so it's pretty cool. All right. Nice. Next thing. I think, yeah, we need to start reading a file, but I'm not gonna use like open and read syscalls to read a file, because fuck that. Let's actually try to use mmap. I never used mmap in my entire life, so maybe that will be relatively easy to do. So mmap, sys mmap. So it accepts quite a lot of things. But I'm pretty sure we can hardcode majority of them. I mean, from assembly, yeah, from assembly. I mean, like I'm trying to think, I'm trying to plan what I need to do and actually explain what I'm doing simultaneously. Just cut me some slack. All right. Slurp file. So we're gonna accept a file through RDI. We're gonna accept the file through RDI. Just wait for the file. This is actually a pretty interesting point. So maybe, yeah, maybe it's gonna be a pain in the ass. Because that will require another syscall, right? So it's gonna be stat. Yeah, fstat, I think. And fstat returns, like, takes a pointer to the structure. Yeah, it's not stat. I think it's gonna be fstat. What's the difference between stat and fstat? So stat syscall, stat buffer, and what's the definition of a structure? So total size in bytes, yeah, this is where you get it from. So it's actually, yeah, it's actually kind of painful. So maybe we're gonna just read that as well. So we can pre-allocate like a big enough buffer. Yeah, the easiest thing here would be to just read this entire thing. So slurp file. This file is gonna accept the file path. It's gonna accept the file path, buff, and buff size. So it's gonna accept these things here. And we'll have to open a file and read that file into that buffer, and then just use it. So and then we will have to split that file into the lines, in lines, right? And then convert each individual string into a number. So that's what we'll have to do here. But before we're gonna do all of that, I think I want to make a cup of tea. So does anyone have any questions about anything right now while I'm making a cup of tea? And I need to bring a bowl to put the leaves in. So yeah, I need to Google. What's up? Does anyone have any questions, chat? Does anyone have any questions? While I'm preparing the tea, you can ask me anything. Feel free to ask me anything. Where do I stand to understand anything? You don't. Just accept that you don't understand anything. You don't need to understand anything. I'm not even joking. How long have you been programming? Check out !FAQ command, it's answered there. Where do you use ASM nowadays? Right here on the stream. Where do you want to store the file content buffer? In a static memory. I'm gonna, so since the input is actually fixed, I can just pre-allocate like a kilobyte. Kilobyte of memory, right, and just put it there. I think it's the easiest way. I'm not gonna even use dynamic memory, I think, in this particular situation. Yeah. Does anyone have any other questions? If you're not CS student, is it bad to try CS job? Depends on the country. I don't know. In Russia, you won't get in jail for that. That's for sure. Like in Russia, there's no requirement to have like a CS degree and doing CS job. Maybe in some countries it is a thing, but I don't know. So I actually worked with a lot of people in CS industry that didn't have any CS degree, and they were just fine. The government didn't try to hunt them down and put them in jail, so they survived. How much tea leaves? I put like around, I think 3-4 pinches. I just don't know how to measure it, to be fair, but I just eyeball it every time. Not that much, to be fair. I just don't really want to make a super strong tea. Yeah. So yeah, I'm gonna go back and Google. Gonna go back and boil up some water. I can never get the amount consistent. Same. I actually, what I essentially do, I just look at the color of the tea, right? And I wait for a specific color of the tea, and then I actually pour it into the cup. So, and no matter how much tea I put it, like I just, the color is more important than the amount of leaves. I want to live in Russia. Trust me, you don't want to live in Russia. All right. Cool. So let's introduce like an entry buffer, right? So we also can define something like entry input buffer. It's not entry, input buffer size. This is where we're gonna keep all of that. Input buffer size, and we're gonna allocate like 1 kibibyte. Is that what kids call these days? This thing these days? Yeah, the entry point is start. Here's the entry point. Yes. All right. So input buffer. How do I allocate like a very specific thing? I think you do it like, it's not D, right? It's I forgot. So the instructions, right? We had db. I think it's res. Yeah, I think it's a res b, something like a res b, and then you do input buffer buffer size. Yeah, there we go. So that allocates me this specific buffer. That allocates me this specific buffer. This is really bad. Okay. Slurp the file. Cool. Syscalls. We need to open, so we need to do sys open. So this is 2. Define sys open. It's gonna be 2. And we provide the file name, the flags. I'm not very sure if we need any specific flags here and any specific modes. We probably can steal that from the C standard library, right? We can steal that. And I'm gonna try to do the following thing, and chat is gonna actually re-at me, and I'm gonna start like getting huge wave of unsubscriptions, like enormous wave of unsubscriptions. But I need to know the the values of all these things. Chat, please don't unsubscribe from me. don't unsubscribe from me. I need to know the flags. Okay, how am I supposed to know them? How am I supposed to know them? Okay. Oh, there's like 2 versions here. That's very interesting. In any case, I think I need to do it like this. stdlib h. Okay. So it's gonna be like this. Flags. What about flags? Show me the list of flags, please. The argument flags must include one of the following access mode. Or read only. We're gonna do read only, I think. So I'm gonna do printf. It's gonna be D. And we will see. Why the chat is so Russian? Why is why the chat? What the fuck is going on? All right. So, and the mode. Mode. Access modes. Okay. O append. But we don't want to O append. O create. Wait. I don't understand. What is the mode? What is the fucking mode? Because I thought it's a flag. I saw the flags. The argument flags must include one of the following flag modes. Okay. In addition, Is that what they are? All right. Open syscall. Let's actually see. Open syscall. Example. So I just want to see the example. Usually they don't use modes. Available value for mode. Maybe I can just put 0 there because, yeah, I think I can just put 0. Mode, a bitwise or separated list values that determine the permission of the file if it's create. Okay, so we don't need the shit. Cool. So we only need or create. Cool. And now I want to just do this thing. Mode is only when you create a file. Yeah, I already figured that. Thank you. So, fuck's sake. You literally put both of the arguments to 0 if you want to just open a file for read only. Holy fuck. What's up, Epic Gamers? How's it going? Welcome back to back. Welcome. He came. Yes, I came back. Okay, then. Okay, then. Now I'm gonna take O read only, and I'm gonna define this motherfucker, and it's gonna be 0. O read only. O read only. Slurp file. So first we need to open this thing. So move rex O sys read. Sys open. Yeah, sys open. So another thing, another one. I think it was something like the where is it? I didn't see. Yeah, there we go. So then RDI is what file name. Okay, so we already have RDI as a file name. Yes, so we don't need to initialize it. RDI already contains the file path, which is kind of cool. So it already contains that, and we need to specify the flags. So RDI, what was that? RSI. RSI is going to be O read only, and then RDX. RDX. RDX is going to be 0, and then we're going to do a syscall, and if I understand correctly, Rax should return you an open file. So, and we also need to do a close, right? We also need to do a close, and it's a syscall, syscall close 3. So it is in fact 3. It is in fact 3. Slurp that file, slurp that file. So, and what's funny, there's nothing funny about that, but still, I want to keep this thing here. One of the things I want to do is I need to push RDI, push RSI, push RDX. RDX. So cool. Because I don't want to like lose them or anything. So this is the file path, buffer size. So this is how we approach all of that. Buffer size. So RDI already contains the file path, and we open this entire shit, and then I need to start reading. So sysread. Do I already have sysread? We only have a syswrite, right? So, and syswrite, by the way, look at that, is sysread. I mean, sysread is actually 0. 0, 1, 2, 3. Read, write, open, close. 0, 1, 2, 3. Isn't that amazing? And exit for some reason is 60. I don't know why, but it's 60 for some reason. It is 60 for some reason. Cool. Finally, I have my tea, by the way. Finally, I have my tea, and it is really, really cold in here. So it's really cold outside, and because of that, it's really cold outside, inside. So I really need some warm tea. Don't you have the magic of Russian central heating? Yes, I do. It's not enough. This is how cold it is today. It's minus 40 outside. I already said that in the in the Discord that I even got an short message from the Ministry of Emergency. They actually warned me that just be careful. Like, there's really cold outside. It's really abnormal weather today. So yeah, it's kind of interesting. That's not a nice weather. Yeah, I know. Minus 40. But that's the price of living in the middle of Siberian forest. I'm not even joking, by the way. I really live in the middle of Siberian forest right now. Minus 40 is abnormal weather in Russia. Okay. Okay. Canada weather. We can actually do something like weather. Weather, Canada. No. Some wimpy minus 17. Don't make me laugh, okay? Canada. Oh shit. Anyway. So, now. Canada. Cool. It already contains the file path, and read. Okay, so we should have ID, opened ID in the racks, and maybe that makes sense to push that ID somewhere there, right? So this is going to be FD, and this is how we're going to operate with all of that. Yeah, so this is opened FD. So push it there. Then I need to start initializing the read thingy. So rex sys read, then in RDI move. Oh, that's very interesting. So I already have this thing in rex. Right, I already have this thing in rex, so I'm calling this thing, so sysread. RSI should contain the buffer, so I'm gonna do push, so it's a buffer size. That's pretty cool. So if I don't push anything here, I can move rex to RDI, then buffer size has to be RDX, so I can do pop RDX and pop RSI. So essentially I pop out these two things. And I just do the proper syscall to read them. I just do a proper syscall to read them. What's funny is that I will probably lose the file that I just opened. I will probably lose it because, and I don't really want to lose it because I want to close it afterwards. No one knows it afterwards. So, but that should just read everything appropriately. And also this thingy should return the size, and we will have to return the size somehow. And the question is how we're going to return it. We can return it through rex. Yes, I think we can return it through rex. Here's an interesting thing. We don't need to save the file. We only need to save buffer and buffer size, right? So because RDI already contains the file path, we just consume all of that and we just open the file. In rex we have the file. So we move this into RDI and initialize this thing, and we recover buffer size and buffer and make a syscall. And I don't really want to lose the file descriptor, so I'm going to push the file descriptor before making the actual syscall. Okay, so I'm going to have this thing on the stack. After that, I need to start doing the close. Do I have close? I think I do have a close. But after the syscall, I want to also not lose rex. Rex is very kind of important. Rex is really fucking important. So I can move it to RDX or something, right? So this is going to be rex. This is going to be rex. And after that, what I need to do, I need to move rex sysclose. Rex sysclose, then RDI becomes, so I have to pop RDI, right? This is quite important. And then I'll have to do syscall. And after that, I'm going to move RDX back to rex, and this is going to be our result. So I think that's going to be slurp the file. So who's keeping the buffer field with new data from the file as you read it, the OS or something below it? That's a very strange question. I wish I could understand what the fuck you're trying to tell me, but I could not understand what you're trying to tell me. So, well, probably the heart. What? Something below it. What? Okay. I'm sorry, like I legit don't understand what you're trying to say. Yeah, so it will be probably better to start utilizing the stack. I want to go through all of these things and just make sure that I didn't fuck it up. So we accept RDI. File path. This is actually very important. RSI, the buffer. RDX, the buffer size. Cool. So we push these things on the stack because we're gonna fuck them up later. We initialize in the open syscall. RDI already contains the file path, and we initialize RSI and RDX, and as you can see, we literally just fuck them up, and this is why we store them on the stack. Syscall. We need sorting function. You don't need that. Alright, so after that, we have in a Rex, we have file descriptor. Right, we have a file descriptor. So we put it into FDI, which is the first argument of read. I initialize the read, and I restore these things that I pushed on the stack. I restored them in the opposite order, RDX RSI. Cool. After that, like as you can see, like if I do a syscall, I'll probably fuck up RDI. I'm not sure if I will fuck it up, but I'm gonna push like RDI on the stack anyway. I make a syscall, and after the read, racks contain the size of the buffer. I don't want to lose it, but at the same time, I don't want to lose. I don't want to override this thing. To be fair, after the syscall, what I can do is essentially pop RDI, and maybe I don't need to do that. I can just do push racks. Yeah. So I do the syscall, then push RDI, syscall pop RDI, then I push racks, and RDI already contains everything I need. I just close it, and then I pop racks. I think that's gonna be the thing. That's gonna be the thing, and that should slurp the file, hopefully, if I didn't fuck it up. Okay, cool. What we're gonna do now, so we have a solve file, right? Do we have a solve file? Yeah, we do have a solve file. So we print it here, right? We print it here. So we push it here, but I would like to actually save it somewhere here, so we can move RSI to RDI because we're gonna reuse it so many times. So RSI RDI, then to RDI I move the input file and print it, and then to RDI I move RSI and print it again, and then to RDI I move RSI yet again, and I try to slurp that file. I call slurp file, and now in the buffer I have everything, so I can try to initialize the syscall. So we're gonna move racks sys right, so RDI becomes the buffer that no, it becomes std out. RSI becomes the buffer, and what I'm going to use as the buffer, I'm going to use this thing, and RDX becomes the buffer size, and the buffer size is actually racks, so I have to be super careful here. So I'm going to push racks, right, and then I'm going to do pop RDX. Are you okay, Hertoplot? Is there any assistance from my side that is needed? Everything's okay? Okay, so cool. Alright, so this is this thing. We print the file path. This is quite important. We're gonna keep it in RSI. Oh, it's gonna fuck it up anyway. It's gonna fuck it up anyway. Everything's okay. The keyboard went crazy. Oh, okay. That's alright. Okay. RDI is the first argument, right? RDI is the first one. Alright, so I'm gonna push RDI. I'm just gonna save it and reprint the input file thing. Then I'm gonna pop RDI and push it again. Right, pop RDI and push it again. And I call println. Then I'm gonna pop RDI and slurp the file, push Rex, prepare this thing, and continue. So hopefully this entire shit compiles. This is not how we compiled, by the way. This is not how it compiles, and there we go. We don't have buffer. So this is because it's called input input buffer. Yeah, that's what it's called. Input buffer. And by the way, I forgot that here I have to do it like so. So RDI, then move RSI input buffer, move RDX input buffer size. So, and essentially what solve file is going to do, it's going to print input file and print that file as well. So we can actually go to the sample.txt, right? And we also can have input.txt, right? We can have that. And that should print everything, hopefully. And we can try to compile this one more time. Input buffer size, this is actually a macro. And initialized space in non-BSS data. Okay, so maybe I will have to have a section BSS. Okay, that looks cool. So I don't remember the history behind BSS and data and stuff like that, but I don't know. So far so good. So far so good. So if I didn't make any severe mistake, so that should just go and iterate through all of the files and read them and print everything accordingly. So let's actually introduce something like inputs. It's going to be sample.txt and then input.txt. And then we're going to have a phony target test. It depends on the inputs, first of all, and it also depends on the main. And I'm going to run main inputs. All right, so let's see what's going to happen. If I try to run it, it didn't actually do anything, but it did print the input files. So maybe slurping didn't really work. But that was interesting, actually. Oh yeah, I know what happened. We didn't do syscall, but at least it didn't sigfall. Look at that. Well, we never called. Yeah. So at least it didn't sigfall, which is actually quite nice. First try, by the way. So essentially, we iterate through all these files, we're slurping them into the buffer, and we're printing them back to the standard output. So we already can read input files and shit. To be fair, it is not more difficult than programming in C so far. I just need to recover a lot of the knowledge because I haven't programmed in assembly for quite some time already. So yeah. And you have to keep track of a lot of things, so yeah, you have to be very careful with this kind of shit. So, what can I say? So we're reading this file and shit. So we read it somewhere here, and we can even forget everything. So, so here's the Rex. We can store this somewhere here. Input buffer size, I think. It could be something like res q, right? So it could be something like res q. And after that, I can move res input buffer size from Rex to here, right? So, and in RDX, I can just move RDX to input buffer size. So, and then we can just, keep track of all of that here. And invalid, okay. Do you have to do it like that? I think you have to do it like that. You have to dereference and shit. Yep. Invalid, oh, 1. Yeah, we have to do 1. There we go. Seems good. Cool. So, so you solve the file, and maybe we need to move some of this stuff to a separate function as well. Something like you have solve file and maybe parse input. This is what we can accept here, and the input is going to be actually file path. So we have RSI. It's going to be file path. So I just want to refactor this a little bit so it's a little bit easy to work with. Yeah. So in RSI, so this is a file path. We already have a RSI in the file path. We have to do RDI. Wait. I keep forgetting what's the order. Yeah, so RDI has to be file path. So in RSI, we have to provide the input buffer size, and in RDX, we have to provide input buffer size as the big thing here, and then we have to call the slurp file thingy, and after that Rex contains everything we need. So we're gonna move input buffer size from Rex to input buffer size. So this is quite important, and I guess that's pretty much it. That's pretty much the whole thing. Yeah. So for the parse input, we only need RSI. So here's the RSI. We already know here. Only RDI. Call parse input. So we also have file path and shit. It would be easier to actually use global variables. I think that's the thing I'm gonna start doing. I'm gonna start using global variables. Push RDI, so input, print, then pop, push, print again, and then pop again. Global variables. Yeah, I think if I use global variables, it's actually going to become easier. So let me do it like that. Input label, input file label, input file label. All right, and then I'm gonna just use like input file path or something. Input file path, and well, it has to be a buffer, right? It has to be, well, it doesn't necessarily have to be a buffer. It could be a pointer, so it could be a resq1, right? This could be a pointer, right? And we can just store it there. So in a solve file doesn't really need any of this shit anymore, right? So instead of doing RDI, so instead of moving it to RDI, you're gonna move it to input file path, input file path, like this, I think. And in here, you don't need to do that anymore. You just move input file label to RDI and print it. Then you move input file path to RDI, print it. Then you move this thing again to RDI, parse it, and you then print the input buffer. So that actually simplifies things dramatically, and input file path can be just a global thing because it doesn't change regardless of anything, right? So I think it's a good thing to have invalid operation. Okay, this one is kind of interesting. Like, I was hoping that you would be able to. Do I have to do it like that? Am I gonna fuck it up? I did fuck it up. Okay, this is actually dangerous. What the fuck is going on? 20 seconds. I confuse myself. Everything's okay, chat. Everything's okay. So RSI dereferences it. RSI contains a pointer. We're dereferencing it. Yes, I know. I think I need a temporary register. Okay, so we'll have to move to RDI, right? And then input file path RDI. I already figured that I need a temporary register. It's just, yeah, there we go. Okay, so I need to start to use like global variables a little bit more more often because they really simplify the code. That's cool. That's very cool. Holy shit. Okay. So what did we do here? We have some garbage in here, but I don't think we need it so far. We implemented parsing the input. 25 parse input. We need another thing, actually, chat. We need another thing. We need to be able to take a sized string, and convert it to an integer. That's what we need to be able to do. You see what I mean? Yeah. Let's implement that. It's going to be yet another function in our standard library. Is everything okay, chat? Well, for some reason, chat is dead. Probably, maybe I hit the point where I do very complicated stuff that nobody understands and people just started to leave. Maybe, I don't know. Or maybe people just see that I'm not getting molded because of programming in assembly, so they think there's nothing interesting here. I don't know, it's kind of interesting. So I guess I successfully shut up those doubters. Anyway, so we need to implement A to I. So what we're gonna accept here, so I wanna actually accept a sized string instead of a multi-minuted one because because we are gonna parse the input from a file, so that means we won't be able to easily modify this thing, so we definitely need to have like some sort of a size string. So RDI is gonna be a buffer, and this is gonna be a buffer size, RSI, I mean. So there we go, RSI. So we're gonna accumulate everything into racks. So we need to modify, initialize the racks. We need to initialize the racks. At least there is no backseaters. I mean, we're losing viewers, so that means people are not interested in what I'm doing. So yeah, anyway. So RDI, so this is going to be the buffer, and I need to start reading through the buffer. Reading through the buffer and keep accumulating stuff into the thing. So it should be pretty straightforward because if I have 1, 2, 3, 4, right, I can easily just grab these bytes and add them to the stop knowing what you're doing setting. Okay, really sorry. RSI with RSI. So we're testing if RSI is 0 or not, and if it is 0, I'm going to jump to the end. Right. This is going to be the beginning. It's going to be the beginning. Cool. So this is the end. Now, what I need to do, I need to take the single byte. We're going to move that byte into, I suppose, a BL. All right, we're going to get it to the BL. After that, so maybe I need to soar RBX, right? Maybe move for BX0 as well, whatever. Right, because I want to, you know, zero initialize it and make sure that everything's okay. Cool. I have this thing. I need to subtract 0 from this thing. That's what I want to do. I want to subtract 0 from this thing. Yes, that's what it is. I wonder if this will work. If it won't work, we can easily just fix it. And essentially what we have here, might as well actually do it like that, like from RBX. So, and we need to first of all multiply racks by 10, and I'm not sure if we can do that. x86 mul, because I think mul is kind of fucky wacky. What are the operands? Opcode, okay, destination performs. Mul example. Function in assembly. Function in assembly. So it uses CX, I think. I don't remember how exactly it works. Does it use BX? Okay, is that the correct one? I see. So it use. Oh, that's actually exactly what I want. So that means I can use CX. Might as well actually move RCX10 and just multiply RCX and add racks RBX. How about that? How about that? Isn't that cool? Cool. That's pretty cool. And after that you have to GMP begin, right? And after that you just return, and racks is going to contain everything you want in your entire life. Isn't that cool? All right, so I want to double check everything. Racks, RBX, RCX. Test. So we check if RCI is 0, and if it's 0, we jump to the end and just return. If it's not, we extract the first character. We subtract 0 character from that character to get the value. We multiply racks by 10. We multiply 10 racks by 10, and we add that character here. After that, we have to decrement RSI. That's very important. Decrement RSI, and we have to increment. I fucked up. RDI. Test RDI. All right, there we go. So we have to decrement RDI and increment RSI. Just like this. You see what I mean? Do I see what I mean? I think it's pretty cool. I think it's pretty cool. So we have A to Y. Now we'll need to test how all of that motherfucker works, and I mean, it compiles and it works. I think it's fucking amazing, mate. I think it's goddamn fucking amazing. So in a solve file, so here we do all of the preparations, we have all of this shit, and the thing I want to do, I want to go into the sample, right, and I'm gonna add 1, 2, 3, 4, 5, 6, and in input I'm gonna have 69. I might as well actually, okay, we're gonna have 420 in one file and 69 in another file. How about that? So this is what we're gonna have there. This is C. You didn't see that, okay? You didn't see any C. I didn't use any C, okay? You're testing RDI. RDI is the buffer. Is that a ban? Is that a ban? Yes, it's not a ban. Okay, so it is RCI. Thank you. I'm already confused. So that means I need to increment that. Thank you so much. This is not a ban. Where's my water? I think I ran out of water. Cool. So now, what I want to do? We printed everything. Cosmetic printing shit. To be fair, I'm planning to actually add that to my CV, so I'm not gonna use shit. Okay, so parse the input, print the input. I mean, I already have links to my screencasts where I swear a lot, so maybe it doesn't matter anymore. Maybe I'm already unemployable at this point. Who fucking knows? So next we have the input, and I want to do move. RDI is the buffer, so it's going to be input buffer. To be fair, I can just do the following thing. I can just copy paste this entire shit. And then call A to I, and Rex is gonna contain that fucking value, mate. That's what's gonna happen. That's what's gonna happen, so that means we will be able to do it like that. The next thing we'll have to do, we'll have to be able to split things by lines, I suppose. Because we'll be able to split things by lines, we'll be able to locate like a window and do some other stuff. Okay. I want to recompile everything. Actually, I want to just make main. Okay, it does compile. Let's do GDB. Break at solve a file. So this is where we're going to break. We're going to run. I think I did a fucky wacky. Exit abnormally. That's really strange. Why did it exit abnormally? It's not supposed to exit abnormally. So if I try to do something like that, and echo, okay. So it means there's something wrong here. Okay, break on solve file and run with sample txt. Then I'm gonna do layout assembly and layout registers, and I want to just see what's gonna happen. Just want to see what's gonna happen. So we're printing some shit. I pressed N instead of NI yet again. Oh, okay. Break solve file, run sample txt. Layout asm, layout registers. Cool. NI. All right. We have everything here. We're gonna print that shit. And then we're gonna print the new line. Okay, so it probably printed something, but I didn't see it printed anything. So we're parsing the input, and I suppose the input has been parsed successfully. I wonder if I can inspect input buffer. Has a known type. Okay, I can cast that thing to character pointer, and it cannot access that specific memory. Okay, that's very interesting. Enter repeats the last command. Thank you, Captain. Very cool. Holy fuck. Alright, so and let's do A to I and see if it's gonna in rack's gonna contain the value. And it doesn't. I think it fucked up completely. Alright, so that was interesting. That was interesting. I wonder why I couldn't print the buffer. That's really strange. Print input buffer. That's unknown type. And even if I interpret it as a character, it still cannot access that memory. Like, why cannot it access that memory? Is it not available? Should be char. Yes, you're right. No. Interesting. All right. Anyway, I need to understand where exactly shit went wrong. Where exactly shit went wrong? So if I... So here's the RSI and RDX... Oh, I'm an idiot. Okay, of course. That explains it. Okay, so let's try to do that one more time. Break solve file, right? Break solve file, run sample txt. Cool. Layout asm, layout registers. Cool. NI. Cool. Parse input. we actually got 3 characters out of the input. It's located in rex, and in sample we, I guess, can also has like new line, I think, and I think that's what's gonna fuck up. I think that's what's gonna fuck up. All right, let me try to do the following thing one more time. Simple txt, input txt. Okay, cool. In both of the cases it works. I'm thinking that oh yeah, it's the other way around. No, it's not the other way around. It's RDI RSI. RDI RSI, RDI RSI, and yeah, where did I make a mistake? So I just need to go through this function. It's definitely the mistake has been done here, yeah, it's gonna be a rex. So in rex we can we actually calculate everything. By the way, let me do the following thing where I don't do that and I only do that, and in RCI I provide like 2 characters. Cool. So here's the counter. RBX is where we're gonna create, this is the counter, this is the character, this is like 10 by which we're gonna multiply. So RSI is the buffer size, right? It's a buffer size. We test if it's 0. If it's 0, we go to the end, boom, by. RDI, here's the mistake, I found the mistake already. So from RDI I put it into BL, and then I subtract 0 from that BL, multiply a rex by 10 and add RBA to rex. Then I decrement the buffer size. It's very important, decrement, and increment the pointer to the buffer and continue to the beginning. I think I found the mistake. It actually compiles so fucking fast I cannot realize that it compiles at all. Alrighty, so now if I try to do GDB main and I break solve file and run sample, layout asm, layout regs, let's go. So after this instruction, rex should contain a 69, and it fucking didn't. Okay, that didn't contain anything. Why didn't it contain anything? So maybe we have to go inside of the A to I. Let's actually go inside of it, because I was trying to look outside of it, so it's going to break A to I. Let's run it on a sample txt, layout asm, layout registers, and let's see what is going on. Okay, so we initialize everything, right? So RSI contains 2. Okay, it is not 0, so we continue. So we move a first character to RDI, right? To RBX. So here's RBX, here's our first character. Cool. I multiply rex by RCX, so nothing happened, but that's okay. I add that to RBX, here's the value. Then I decrement RSI, so it becomes 1. Increment RDI. Right, so it goes to the next character. Cool. And I jump to the beginning. Nice. So I check RSI again. It's not 0. So that means I continue. RBX has this. Makes sense. It's actually 9, so this is 69. I multiply rex, so this is 60. And I add, we have 69 in rex. Cool. So I decrement RSI, so here's the RSI, and then increment RDI. Cool. But after that, RSI has to be 0, so we set flag to ZFS, and we go to the end, and then we return, and I don't see any mistakes here. Alright, I call, and here's the rex. It does contain, it works? Did I forget to, yeah, it works. There we go. It works. It does exactly what I wanted. I think maybe I pressed N at some point, but it works first try. Okay, it does work. I think I just checked it incorrectly. it actually works. You see in Rax we have 69, so that means it actually read it correctly. All right, it read it correctly, which is nice. And the next thing we need to do, we need to read things line by line. We need to be able to read things line by line. So to do that, I need to be able to search for a particular character in the buffer, right? So I need to search for a particular character in the buffer. So let me show you what I mean. Let's implement index of. So in RDI we have a buffer, then we have RSI, which is a buffer size, and then in RDX we have the needle, the thing that we're searching for, and Rax is going to return needle index. Right, so this is what we're looking for. You see what I mean? You see what I mean? Yes, that's what I mean. We might as well maybe return a pointer. I'm not sure. Which can be better. Okay, so the thing we can do. So Rax, actually, we can do AL. Right, we can do. I don't remember AL. It's a lower bit. Right. Okay, so we're gonna put that in Rax anyway. When I do Rax 6, where 6 is located? In AL or AH? I think it's located in AL, right? Do I understand it correctly? So it's located to the thing. It's located in AL. Okay. str chr. Well, but that one actually operates on the null-terminated strings. In our case, it's not null-terminated, but I can call it as str chr. Sure, chr. Why not? And what does it return? Does it return like the... Oh, it returns the pointer. Okay. Seriously? Really? So it accepts const pointer to this string, but returns a non-const one? The fuck? Return the pointer to the matched character. Holy fuck. Who needs const cast in Alright. That's very funny. Okay. Didn't expect that. Alright. Okay, so now what we need to do, we need to move AL RDI, right? So AL RDI. And then I can do something like test Rax, test Rax with RDX. Well, first we need to test RSI with RSI, and if it's 0, we go to the end. Right, we go to the end. And end is located here, and what we essentially do in the end is what? Well, we can just do move Rax RDI, right? We can just do something like this then. Alright, so we test that, and we might as well put begin here. So then we move RDI here, we test... is it not test? I think it's CMP. So CMP, x86, CMP. Compared to operands. Okay, so I think we need to use CMP. CMP, does CMP modify anything? I forgot what's the difference between test and CMP. I forgot. Ah. It's almost identical. Okay, it's end. Okay, thank you, it's end. But is it? CMP is a subtract is a bitwise. You mean test? Okay, so CMP is a subtract. Cool. So now, not really sure. Test is a bitwise. Okay. Now I'm subtracting that, and if they're equal, I jump to the end immediately. I jump to the end, and then here I jump to the begin. But before I jump to the begin, I have to do increment the buffer and decrement the size. There we go. Alright, cool. So essentially this is how we begin. We check if we already checked everything, and I just return that. What's interesting is that, can I just move -1 to Rex? Is that a thing I can do? Alright, so initially I moved it like that. It's not gonna help. Fuck. So... Oh, it's gonna be after the end of the buffer, so that's the indication. It's gonna be after the end of the buffer, so that's the indication that we didn't find anything. That's the indication. Okay, does that, then we take the character. We might as well actually soar. Why use Rex for needle index when you just can use RDX? Rex is a result. I don't understand what you mean. Rex is a result of the operation. I'm sorry. Okay. So everything looks okay. Now let's continue. So that should help us to split everything by lines, right? It should help us to split everything by lines. We don't need to print anything here. We don't need to print anything here, and that's how we're gonna go about that. So we start with CHR. Okay. We move RDI. The size goes here. And the thing we're trying to find here at the middle is going to be a 10, right? So, and Rex is going to contain, and then we'll have to call CHR, of course. We have to call it. We have to call it or something. We have to call it. CHR. So I'm just calling it, right? So, and it will give me, in Rex, it will give me the location. So essentially, yeah. Now, if you do Rex minus input buffer, Rex means input buffer. Input buffer contains the pointer, right? Input buffer contains pointer. You'll get the size, essentially. You'll get the size as well. You will get the size as well. It's kind of strange. Like, why do we have to dereference this thing here? They don't have to dereference this thing here. Oh, because it's okay. That's cool. So that's gonna be the size. Cool, cool. And then I can just parse everything properly, and we can do that in a series, right? Until we reach the end, right? Until we reach the end of the buffer, right? And testing that is actually kind of interesting, but we don't really have to do that. If you ask me, we don't really have to do that because we have a fixed amount of things anyway, right? We have a fixed amount of things anyway. I think, yeah, we have pretty much everything we need, except we don't know how to print numbers. Yeah, I think we just don't know how to print numbers. So let's actually learn how to print numbers. But we need some sort of a number buffer. Time for A to Y. I mean, obviously, how else would you do that? Okay, A to A. And this is going to be return, and what we're going to have here, RDI is going to contain the number, right? And yeah, it's going to contain the number, RSI is going to contain the buffer, and RDX is going to contain the buffer size. There we go. So it's going to contain buffer size. So, and essentially this is what we'll have to do here. And this one is very interesting if you ask me. Okay, I want to make a cup of tea. Does anyone have any questions about what we're doing? Or like generally some questions about something? Does anyone have generally questions about something? I think it's cancer, thanks God it's not cancer. What are you talking about? I'm making a cup of tea. How much faster will it be than Python? I have no idea. Any other questions? Maybe interesting questions? I really appreciate interesting questions, by the way. You know, the questions that actually, like, you know, stimulate your brain and force you to think about things. Something like, you know, actually interesting. How do I tell my friends that I have a food fetish? Just tell them. Next question. I'm making a cup of tea. I'm not gonna do anything. Like, just ask me a question. Yeah. So. I was thinking, but I'm not sure if I would look good. I wish there was like some sort of app that would show you how you're gonna look bold. But I mean, there is probably some filters. But the thing is, they don't really know the shape of your skull, right? It just depends on the shape of the skull. Would you consider RISC-V machine, provided it has NixOS support? What a silly question. What are you talking about? How would you write it in .NET CLI? With my hands. Is assembly worth learning if you already know Node.js? No, it's not worth learning. If you're programming in Node.js, just keep programming Node.js, don't think about anything else. Alright, so I'm gonna go to the kitchen and I'm gonna turn on the kettle, and then I'm gonna go back. If you're considering to learn a language for your next career move, don't even bother about such things as assembly. Obviously, you miss the point. Just keep programming in JavaScript, don't think about it. Yo, what's up? I'm back. Too bad. A2I. I haven't really tested how strchr works, but maybe we should do that. Maybe we should test it. So let me see if I provide like two things here, right? So now in a sample, I think it was a sample, right? It was a sample. It was a sample, so we parse the input, right? And in RDI, so it's gonna be input buffer size. I provide the input here. strchr. So in RSI, I provide the buffer size, input buffer size, and in the thing here, I provide the needle. So we're looking for this thing, and then I call strchr, and then we can try to see if we found anything, if we actually found anything. All right. So let me try to compile all of this stuff, and it does in fact compile. It does in fact compile, and let's go. So it's going to be solve file, and just run it with the sample txt, layout asm, layout regs, and let's go. Okay. So we parsed the input, we successfully parsed everything. So I suppose here we are. What are we initializing? Wait a fucking second. Input. Oh shit. And I like how it compiled. Like I made this mistake all the time. It's kind of interesting how I found the mistake in the debugger. So yeah, instead of like putting the size there, I put like a pointer to the size, which is not correct. Break solve file, run on a sample, layout asm. Can I have like two of them? Can I have two of them simultaneously? No, it has to be a separate thing. Okay, sure. So we parse the input, then in RDI I put the buffer itself, then in RSI I'm gonna put the size of the buffer, so there's like 7 characters here, which is correct by the way. 2, new line 3, 6, new line 7, there we go, 7 characters, cool. So, and I put the needle here, so here we have a needle, and in... Why does it always exit abnormally? There's something wrong with... There's something wrong with the debugger. Like every time I call any of these functions, they exit abnormally, but if I look inside of them, they're like not. And it's really strange. It's exited... Oh, it's exited normally. Okay, I'm sorry. I'm an idiot. And Rex should have... Why did it exit? Why did it exit? Why did it exit at all? Okay, so it doesn't change the fact that it's really weird, and it doesn't give me an opportunity to finish things. It doesn't change really anything. Normally, abnormally, it just acts weird anyway. So it doesn't change anything. All right, so I'm gonna break on here and layout asm. There we go. RSI. In RSI we have 7, and so do I need to initialize anything? Okay. Cool. In Rex I have this, and then a CMP, and it's not that. Increment, decrement. So RDI is a buffer. Then we go back. So after that one, we still should have that. And then here's the 10. Here's the 10. Go to the end. We're in the end. And we have the address of this mother flipper. Cool. So if I take a look at the buffer, print buffer, input buffer, Can I subtract? And if I subtract literally this value from it, will it be 2? Okay. Input buffer, well, sure. Nah, it's the other way around. Because it's smaller. It is smaller. So input buffer. Okay, my tea is probably ready. So what am I moving there? I should actually move RDI, and yeah, I'm increasing RDI, so it's actually bigger. So it should be okay. So it's very strange, but yeah. All right. Ah, fuck. Shit. I don't know how to operate a French press, apparently. I wish there were easier ways for me to test things, but I don't think so. So, RDI, here it is. CMP, if they're equal, and RDI becomes that, and I think everything's okay. It's kind of interesting. If I print input buffer, so what if I interpret it as a pointer? It's actually too big for a pointer. Like, why is it so big? Is that... Wait a second. Have you been since the beginning of the stream, Lab7? I think you missed the beginning of the stream. I would recommend you to watch the beginning of the stream. Thank you everyone, by the way, for the support. I really appreciate it. Okay. It's really, really strange. Not quite. Well, I mean, yeah, so I would really recommend you to not make this kind of assumptions and writing me a wall of text and distract me from trying to solve the problem. Thank you very much. All right. So, what I wanted to do. So this is the input buffer. Chat is like, it's actually not worth reading the chat because people don't even try to help you. They literally try to distract you, and that's the only thing they do. All right. So this is the input buffer. This is the buffer size. So CHR. I need to check if RDI actually in fact contains what I think it contains. Because I think yeah, that is like that. Break solve file. Break solve file. Let's run it in a sample.txt. Layout asm. So this is what it is. So then we press it, and this is what we move to RDI. And what's funny is that it's supposed to be equal to input buffer size. In buffer size, it has something to do with segments. It has something to do with segments. I'm pretty sure about that. input buffer. So if I interpret this as an integer, yeah, but I know that this is the beginning of the buffer, so that's why I couldn't understand what the hell is going on. So this is the beginning of the buffer. Then we are preparing for everything, and let's step into the call. Okay, so we're gonna make 2 iterations here. So we're gonna make 2 iterations here. So this is the second one. And on the third one, we'll realize that we have to step out. We put this thing here, and this is the result of this entire thing. Right, it is bigger, and if I take it and subtract here, I should be able to, for example, take something like this, and it is 2, it is the size. Okay, cool. And of course, yeah. So I just need to ignore the chat. That's basically what I need to do to solve the problem. So it's kind of interesting. Like, it does have something to do with segments and stuff like that. But I don't know really much about them. I don't really know much about them. Which is kind of strange, right? So, yeah. Okay, I think this function works all right. This function works all right. Hey chat, is learning GDB worth it? No, it's not worth it. Keep programming in JavaScript. Don't even worry about it. Okay, I to A. So we have a number and we need to put it into the buffer. The problem with this kind of thing is that you can, yeah, you will only be able to print it in the reverse. Yeah, so you only will gonna put it in the reverse. But maybe we don't need that. We can probably read the final result from the standard output, I think. I think we'll be able to do that. Okay, so I'm gonna postpone this entire function for now. Right, I'm gonna postpone it for now. Exit. All right, so I'm gonna exit. So this is gonna be my assertion, by the way. This is gonna be my assertion. So I'm essentially exit with 69 code here. All right, and if I accidentally use it, you can reverse. Okay, I'm not reading the chat. So let's actually finally read the description, because I think we have pretty much everything to solve the problem. We have pretty much everything to solve the problem. So I can technically parse the input. I can convert strings to integers, and so I just only need to do the algorithms and stuff. So should be enough. Should be enough. Let's take a look at the advent of code. So maybe some. Okay, I'm gonna make a small break because I need to reset my brain, because I've been actually very actively thinking how to implement all of that, and I think I successfully did all of that despite, you know, chat not wanting me to do that. So does anyone have any questions, by the way, like, you know, like legit questions? Because my answer will depend on the quality of your question, by the way. If you are gonna ask a chat question, you're gonna receive a chat answer. So I'm just making a small break, and maybe we can talk about something. Do you want to ask me something? So yeah. Let me just drink a little bit of tea and you can ask me anything. May you show A to A code? Sure. There we go. Scroll into proc, please. I don't know what you mean by that. Does anyone have any other questions? Feel free to ask anything. Did it get harder than a C at any point? Harder, I don't know, in terms of like semantics, in terms of a semantic, it's not harder than C. I would say. In terms of the syntax, it's harder than C. So I don't know if it makes any sense, right? Semantics is still the same. It's still like memory, continuous memory, consistent of bytes, and it's still pointers, and it's just manipulation of pointers. Is that syntactically it's a little bit more difficult to do all of this, if you know what I mean. I'm not sure if it makes sense though, but yeah. Okay, sure. Yeah, so it's just easy in C because some of this stuff, like syntactically, is automated, right? Does anyone have any other questions? In assembly, you need to deallocate local variables. Well, if you allocate them on the stack. Like passing variables to functions. Well, what's interesting is that if you pass variables via registers, you don't have to deallocate anything. So you just don't have to do anything. So, have you done any calculator real? No, I've never done anything like that. I'm not a low-level programmer. I'm sorry. I'm a Java enterprise developer, so I'm not like, I don't really know much of this low-level stuff. It's not my thing. I don't see any contradiction with my previous statement here. Any other questions, maybe? All right, let's go into solving all of that shit. Let's go into solving all of this shit. Okay, combo breaker. You finally reach the check-in desk. Unfortunately, the registration systems are currently offline and they cannot check you in. Noticing the look on your face, they quickly add that tech support is already on the way. They even created all the room keys this morning. You can take yours now and give them your room deposit once the registration system comes back online. Okay. The room key is a small RFID card. I don't know what is RFID. Radio frequency. Okay, cool. Your room is on 25th floor and the elevators are also temporarily out of service. So it takes what little energy you have left to even climb the stairs and navigate the halls. You finally reach the door to your room, swipe your card and beep, the light turns red. Examining the card more closely, you discover a phone number for tech support. Hello, how can we help you today? You explain. Holy fuck. Well, it sounds like the card isn't sending the right command to unlock the door. If you go back to the check-in desk, surely someone there can reset it for you. Still catching your breath, you describe the situation, describe the status of the elevator and the exact number of the stairs you just had to climb. I see. Well, your only other option would be to reverse engineer. What the fuck is this? Your only other option would be to reverse engineer the cryptographic handshake the card does with the door and then inject your own command into the data stream, but that's definitely impossible. You thank them for their time. Unfortunately for the door, you know a thing or two about cryptographic handshakes. Why did I read this shit? Like, why did I have to read this? And it contains zero information. Okay, the handshake used by the card and the door involves an operation that transforms a subject number. To transform a subject number, start with the value 1. Then a number of times called the loop size, perform the following step. Set the value to itself multiplied by subject number. Set the value to the remainder after dividing the value by 2020. What is this date? 27th. Is that a Conway's date? No, it wasn't. What is this date? What is it? Is that today? I don't think so. Oh well, whatever. I'm dumb anyway. The card always uses a specific secret loop size when it transforms a subject number. The door always uses a different secret loop size. The cryptographic handshake works like this. The card transforms the subject number of 7 according to the card's secret loop size. The result is called card's public key. The door transforms the subject number of 7 according to the door's secret loop size. The result is called door's public key. The card and the door use the wireless RFID signal to transmit the 2 public keys, your puzzle input, to the other device. Now the card has the door's public key and the doors has the card public key. Because you can eavesdrop on the signal, you have both public key but neither device loop size. The card transforms the subject number of the door's public key according to the card's loop size. The result is the encryption key. The door transforms I don't understand. I didn't understand any of this shit, to be fair. The door transforms the subject. Okay, whatever. If you can use the 2 public keys to determine each device loop size, you will have enough information to calculate the secret encryption key that the card door used to communicate. This would let you send the unlock command directly to the door. For example, suppose you know that the card's public key is this. With a little trial and error, you can work out that the card's loop size must be 8, because transforming the initial subject number of 7 with a loop size of 8 produces this thing. Then suppose you know that the door's public key is this. By the same process, you can determine that the door's loop size is 11, because transforming the initial subject. At this point, you can use either device loop size with the other device public key to calculate the encryption key, transform the subject of this into this. What the encryption key is a handshake trying to establish? I have no idea. Oh, it's actually a prime number. Nice. We can actually double check that. Nice. 2020. Huh. Wait, it's tomorrow. Isn't it gonna be like some sort of celebration tomorrow? Ah, no. The Americans use a different format to write the date, so it's not gonna be a celebration. Let's celebrate. Well, we can celebrate that, but if Americans don't celebrate that, well, is it really a thing worldwide? Anyway, okay. So what is the puzzle input? I literally don't understand what the fuck is this. It's like some stupid mumbo jumbo. Okay. Okay. The handshake used by the card and the door involves an operation that transforms a subject number. To transform a subject number, start with the value 1, then a number of times called the loop size. Okay, I literally have to, for fuck's sake, I literally have to do that. So, subject number. Okay, to transform a subject number, start with the value 1, then a number of times called the loop size. Perform the following steps. Like loop size is the number of steps. Set the value to itself. Okay, you have 1, right? You start with 1. Start with the value 1. Set the value to itself multiplied by a subject number. Okay, so here's the subject number. Okay, you could have just given me a code or something. Set the value to the remainder after dividing the value by this thing. Okay. Cool. The card always uses specific secret loop when it transforms a subject number. Okay. For I in 0 loop size. So that's what you want from me. Holy shit. Okay, like, I don't know if it's something wrong with my brain or the tech is so bad, but I cannot visualize the process if people describing me like that. Like, I cannot understand what they're talking about unless I just follow it very closely, write down like a proper code. Now I can see what they're trying to tell me. So is it only me, or is the text actually bad? Because sometimes I feel like it's me, because I saw a lot of people just briefly, look through the text and instantly understand what they're told. Like, I cannot do that. Is it me? Because I think I'm dumb. The card always uses very specific secret loop size when it transforms the subject key. Okay, very interesting. Well, Excel site, whatever. It's the details. I got the main idea. All right. I think it's normal to have a hard time understanding this text unless you are used to work with such algorithms. Which algorithms? 3 times 2, it's hard to understand the text. Yes, it's just really bad. The guy was so okay, and subject number. The cryptographic works this way. The card transforms the subject number of 7. Okay, so we can have something like transform. Transform subject number. Okay. Okay, so this is the transform, and we pass the subject number there. Okay, cool. So this is what we have here. The card transforms the subject number of 7 according to the card's secret loop. Okay, transform. We might as well actually accept the loop size here as well. Subject number of 7. Card public key. So 7 card loop size. Okay, so this is the first thing we do. So we have a card public key. The door transform the subject number of 7 is door's secret loop size. Door public key is the same. Okay, so we just replace card with door. Cool. So we have that. The card and door use the wireless RFID signal to transmit the 2 public keys, your puzzle input. Okay, so my puzzle input is car public ID and door public ID. Cool. The card has the door's public. Okay. Now the card has the door's public key and the door has card's public key because you can eavesdrop on the signals. You have both public keys but neither device loop size. Okay. The card transforms the subject number of the doors. The card transforms the subject number of the door's public key according to the card's encryption key. Okay. Transform door public key card loop size encryption key. Door transform the subject number of the door transforms the subject number of the card's public key according to the door's loop size. Okay. So card door. Okay, and you have to actually, yeah, so the most important property here is that these 2 things have to be equal to each other, right? They have to be equal to each other like this. Okay, the result is the same as the card calculated. Okay, if you can use the two public keys to determine each device loop size, you will have enough information to calculate the secret encryption key. If you use the two public keys to determine each device's loop size, you will have enough information to calculate the secret encryption key that the card and door use to communicate. This would let you send the unlock command directly to the door. For example, suppose you know that the card's public key is this. With a little trial and error, you can work out that the card's loop size must be 8. You basically just brute force it. Okay. Then suppose you know the door is that. Okay. At this point, you can use either device loop size with other device public key to calculate the encryption key, transforming the subject number of the door's public light with a loop size of 8 produce the encryption key. Okay, transforming loop size. What encryption key is the handshake trying to establish? Okay, I understand the problem now. Holy shit. Like, it's kind of surprising how some people can just read through this text and instantly understand that, like, without, you know, doing these things. I think I'm, like, literally retarded or something. Holy fuck. And you need to find loop sizes. Thank you, Captain. Very cool. Okay, let's do that. So maybe first thing we're gonna do, we're gonna implement the transform function, right? So which will accept subject number and loop size and shit like that. All right. Algorithm txt. So yeah. So we know both public keys. Yeah, I think we just need to do a transform. Just need to do a transform. To be fair, I should have not listened to the chat and just, yeah, whatever. I mean, I already promised anyway. Okay, transform. Chat, are you ready? Are you ready for a transform? So it's gonna be like this. So RDI. RDI is gonna be a subject number. RSI is gonna be loop size, right? So it's gonna be just implementation of transform, and it will return as the thing. What's funny is that I think it's pretty straightforward to translate that to assembly, right? Because X is gonna be Rex, right? So you start with 1. And then you do have begin and end. You have begin and end of these things, right? So here's the begin and end. Then we test. So loop size. We're doing a loop size. I guess if someone does a competitive programming, they find patterns in the problem so they understand it faster. I guess that's what they do. If it's 0, JZ, we go to the end, and that's gonna be it. If it's not, so subject number. That's actually pretty cool. That means I can just literally do mul RDI, and that will work, by the way. That will work, but division is gonna be a little bit more difficult. Oh, holy shit, it's so easy to transform into assembly. Okay, so x86 div, unsigned division. I need example, I think, because I don't really understand, you know, this formal. This is not what I wanted. Okay, I wanted this one. Come on. So, always divides 64 bits value according. This is not helpful. The result of division is stored and the remainder in EDX. Okay, clear the divide end. Okay. So dividend divisor. Okay. Then we do a division, and DX is going to contain the remainder, and this is the only thing that we care about. Right, cool. So maybe we're gonna move RCX 2020 27. Right, so we multiply by RDI and it's saved back into Rex, and if I do div RCX, right, div RCX, yeah, before that we probably want to move RDX 0 to clean it up. And then we divide it again, and we only need the remainder, so that means we'll have to move Rex. We'll have to move Rex. We'll have to move a Rex. A Rex. RDX. So after that, we'll have to jump to the beginning. Not really. We'll also have to decrement RSI, if I understand correctly, so it's going to be group size. I think that's it. I think that's the transform. If you ask me, I think that's exactly the transform. That's exactly the transform. Yes. So how could it be useful? I want to test if it works correctly. Do we have any interesting stuff? So if you, for example, suppose you know that the card's public number is this. Little trial and error, you can work out the card's loop size must be 8. So essentially what we can do here is so cards, it starts with 7, right? It starts with 7, but at the same time, let me see if it's gonna work. Okay, so wait a second, what we're doing here, we keep on multiplying by subject number and by modulo of this thing. Oh yeah, I see. Can you even speed it up? It's literally just a modular thing. It's essentially subject number. It's literally subject number to the power of loop size mod 2020. Difficulty through obscurity, by the way. Difficulty through obscurity. Holy fuck. Really? I wasted my time just to realize that this is like, and it's not even the challenge by itself. It has nothing to do with the problem. It's just like the challenge of trying to comprehend this text. This is so bad. This is really so bad. And this could boil down to some, you know, yet another Chinese cartoons theorem or whatever. Okay, so it's that thing then. So that's the whole transform. I'm not thinking about anything, I'm just tired. I'm just a little bit tired, so only issue if loop size is massive. Thank you, Captain. We have so many captains in the chat. Holy fuck. Okay. So what I want to do, I want to just test it if I didn't fuck up. Can anyone tell another obvious thing? Maybe somebody has a question. I want to make a small break from this shit. Does anyone have any questions, maybe? You know what? Fuck you. I'm not gonna read it from input. So, because it's just too much work. It's not even that interesting to read. I can do that, but it's just too much work. So I think I'm gonna get rid of all of this stuff. The PC spec, check out FAQ. More. Spam that person with FAQ until they see that. Just more FAQ. Alright. So I'm gonna remove all of this shit. Maybe... yeah. So what do we have here? More parsing and stuff like that. So first I want to actually commit everything. So 25 more parsing. I'm gonna push that into this one. Okay. Cool. You know, like seriously, fuck it. I'm not gonna do file reading and shit like that. It's literally a waste of time. It's not helping anyone. I'm removing all of this stuff. So we're only gonna like only gonna hard code all of this information into this stuff. So I'm not gonna slurp the file. Fuck all of that. There's just too much work. I can do that, but it's gonna be like the whole project of doing this entire stuff. And obviously we can do that way faster by simply not doing that. Literally. Literally by simply not doing that. Yeah. So I'm gonna remove that. I demonstrated that I can do that, so that's it. I'm done with that. So so we have a card public key, right? So where do we have a card public key? So for example, suppose you have a card public key. So this is the card's card public key, and it's DQ. It's a DQ, and it's equal to that. So this is the card's public key, and we can have something like a door public key DQ. I should never listen to chats, holy fuck. I'm actually like regretting listening to the chat and accepting the idea of implementing like everything. No, it's a waste of time. Go away from me. Okay, so here's the thing. So we're gonna do it like that. And yeah, we can just try to iterate through the loop sizes. And decode loop size for that specific thing. So, but the question is how we're gonna do that specifically. So we're gonna start with Rax. So a loop size could be, yeah, we can start with 1. All right, we can start with 1, and it's gonna be begin and just end. Right, and it's gonna be end. It's gonna be just GMP begin. GMP begin. Cool. And how we're going to transform all of that? So it starts with a subject number, so that means move RDI to subject number what? 7, and loop size is going to be, yeah, I can just use RSI for the loop size. I think that's going to be cool. So it's already there, and I can just call transform. And Rax is going to contain the thing. Alrighty, this is interesting. So RDI, but before I can call anything, I'll have to push RSI, right, the call transform, and Rax is going to contain things. We're comparing Rax with the card public key, right? We're comparing it with card public key. There we go. And if it's equal, we jump to the end, right? We literally jump to the end. And I want to also get like a result label here, so I can actually break on it and look at the final result. And the final result will be contained in Rex, I think. No, we keep incrementing RSI. All right. So, all right. So, so transform and pop RSI. Cool. So push RSI, transform, pop RSI. Cool. So we compare and we go to the end. Otherwise, we increment RSI. So we just basically iterate through different loop sizes until we find something, right? Until we find something. And after that, in the Rex, we're gonna have, actually not in the Rex, but in RSI. So RSI is gonna contain the final loop size, right? If you know what I mean. So it does compile. So that means then in the debugger, we can do GDB and break on the result, right? Break on the result and just run this entire thing. And I'm taking a look at the register RSI, and RSI contains 8. And is it 8? It's not really 8, which is kind of interesting. It's actually 7. It's 8. There we go. We found it. It's 8. So yeah, in the register we contain the 8, and there we go. We actually confirmed its size. Maybe it would make sense. Maybe it would make sense to extract this entire thing into a separate procedure as well. So something like crack loop size. You know what I mean? Crack loop size. So in the subject number, yeah, I think we're gonna only accept the subject number. Yeah, we're only gonna accept the subject number. So RDI subject number. So here we do return, and I wanna copy paste this entire thing here. So a subject number is going to be 7 here, right? 7 is going to be in RDI. Oh yeah, that's very interesting. Do we even modify RDI at any point anywhere? Well, I mean, yeah. So we'll have to push RDI. Pop. Then I do pop RDI and push RCI. Oh boy. Okay, I think I'm gonna transform that a little bit. Yeah, so RSI is initialized with that, subject number is that. And before calling transform, we're pushing both RDI and RSI. RDI and RSI. We call transform and we're restoring them like this. We're restoring them like this, then we incrementing RSI and we're going back and we're going back. All right, so once we found in Rex the public key, oh, we actually have to, goddamn. We also need to pass the public key. Yes, we also need to pass the public key. So RDI subject number and RSI is going to be public key, because this is the call convention, right? It's a call convention, and Rex is loop size. Rex is a loop size. Because of that, I think I need to rewrite all of that. So this is a subject number, this is a public key, and transform accepts subject number, but loop size here. So we'll have to be a little bit more careful. All right, so I need to restart this entire stuff. So we're starting with Rex 1, begin and end, jump to the begin. There we go. so the first thing we're trying to do, we need to maybe save everything before doing any transformations. We're gonna do push rex, push RDI, push RSI, push RSI. We save everything. So RDX already contains what I wanted, subject number, but RSI doesn't contain that. So RSI needs to contain rex. It needs to contain rex, and then we call the transform. And in rex we contain we have the final thing. In rex we have the final thing. We have the key which we need to compare. So how we comparing it? Compare. Compare CMP rex with the public key, and the public key is located where? Holy shit! Oh fuck! Okay, so I need more. Okay, was it too loud? I'm sorry if it was too loud. Pop RSI, pop RDI. So I restore these things. Compare rex with RSI. If they're equal, we're going to the end. We're going to the end, but that's not really enough, because then I'll have to also pop rex. Right, I also have to pop rex. And this is also another thing. It was too dang. Okay. Pop rex, increment rex as well. Okay. Okay, so first we initialize rex, then we save all of that in the stack, and we call the transform. We partially restore RSI and RDI, and then we can compare rex with RSI with the public key, and if they are equal, we go to the end. By going to the end, we also restore rex. Then we also restore rex here. We might as well actually do something like, can we do it like that and get rid of the pop here? I think we can. Right, compare rex, pop rex, and just go to the end. And yeah, I think we can do something like that. So this should actually compile. This should actually compile, and we can crack the loop size. So subject number for 7, it says subject number 7 and a public key. Cool. Move RDI. Subject number is 7. RSI is card public key. Okay, cool. Yeah, we don't need that shit anymore. Cool. So this is the public key, and then we're gonna call crack loop size. Move RDI 7. Move RSI door public key. Call crack loop size. There we go. That will compile. It did in fact compile. So we can do GDB main break start. Let's run it and layout ASM registers. Cool. So what we're looking for is first should be 8 and the second should be 11. Let's see. We're ready to call rex. Fuck. Didn't work. Because yeah, that's very interesting. So rex, we push that, then we call transform, pop RSI RDI, compare this thing. It could be, yeah, it could be because of that. Could be because of that. Not really sure, but maybe. Break on start. Run layout ASM layout registers. Okay, I fucked it up. Okay, I need to be really careful. RDI subject number and loop size, and subject public key. Public key. So subject number is already RDI. I only need a loop, and then I can transform everything. So now Rax contains a public key. I can pop RSI and RDI, and I need to compare with the public key. So I compare them. If they're equal, I go here and I pop Rax, and that should actually give me. If they're not equal, I pop Rax, increment the Rax, and jump to the beginning, which will push Rax back again. So where did I make a mistake? I don't see any mistake anywhere. I didn't deref. Fuck. Thank you. That makes sense. I keep forgetting that. Yeah. Type safety, by the way. Type safety, by the way. 8. Here's 8. Here's 11. So we cracked both of them. Cool. Thank you, Zhiyang. Yeah, I'm not a really good programmer, you see. I also, by the way, you probably missed, but I also ditched the whole idea of implementing libc runtime, because it's just too much effort. Like, it's not that difficult. I can do that, but it's just like the size of a separate project of several streams. So I just decided to hardcode these values. I'm sorry, I'm not as good not a god coder. Okay, so we understand our loop size. Cool. So what's the algorithm? So okay, and since we know the card loop size, we can use Doors public key, and we can just transform it, and that will give it an encryption key. And they should be the same, by the way, but I'm not gonna check if they're the same or not. Key is the handshake trying to establish. Okay, so that's actually pretty straightforward. That is actually pretty straightforward, and let me see if I can do that. So I only, okay, card loop size. So I'm only gonna do that, so it contains only this thing. So I want to move Rax okay, so RSI. Subject number in our case is door public key. Okay. Emacs, please not. Move RDI door public key. So here's the door public key. We have to dereference it. Holy fuck, we have to dereference it. And RSI is the loop size, so it's literally located in Rax. Cool. Then we can transform, and Rax is going to contain everything we wanted to see. And the encryption key. Do we know encryption key after that? Okay. At this point, you can use the transforming that produces the encryption key 148. So we're expecting something like this. Right, we're expecting something like this. And if I try to run that, let's actually go away from here. Break start. Right, I'm gonna run this thing. Layout ASM. regs. Okay, we established it as this. RDI contains 178, which is a correct value. Then RSI is 8. Transform. Look at that. 148.97.078, and this is exactly what we have here. I think that's exactly what we have here. I think we have a first solution, by the way. Alright, so this one is going to be a sample. It's actually super easy to do in assembly, holy fuck. Yeah, and input. So let's take a look at the are they in the same order? I'm gonna assume that they are in the same order, essentially. So yeah, we can remove that, and I'm gonna put it like this, and this is gonna be our thing. We recompiled all of this, and let's restart it. Didn't the last number of the key varies from the... I think something went wrong. Why? Is it too slow? But I mean, did I miss something? I could probably miss something. Alright, so I'm not sure if I made a mistake or is it just too slow. So if it's just too slow, I can try to do something about it. If it's just too slow, because it's essentially well, we can do a binary power. But I mean, the input is not that big, is it? Is it not? I don't think so. Like for that specific, if you take a look at that, like it's not that far away from whatever we have here. The algorithm looks correct. If it works on a sample, it should work on the actual. So that means it's slow. It means it's simply slow. I'm just thinking, should I just wait a little bit and just see? Okay, let's try to wait a little bit. It's just slow. Okay. So it could be. What do we do, by the way, in the crack loop? I already forgot what we do there. So we just do transformations, and in transformation we just, let's check that. Assembly code is slow. It broke the stereotype. Wow. Well, I don't even know where to start. Let me guess. Do you have like a formal education in CS? Stop gaming 15. I'm gonna guess that not. Tell me that I'm correct. Do you have it? Okay, so it's just that slow. We're gonna assume that it's just slow. So how we can optimize this thing? It's as already mentioned. The reason why I'm saying that you don't have a formal education in CS is that if you had it, you wouldn't find this joke funny. It's not because it's not true or anything. Is that because you've probably made that joke so many times, you're so sick of it. If you're like in CS circles, you would probably make it so many times that it won't be even funny for you. Alright, so let me see. As I already said, it's just a power, right? And there's an algorithm called binary power. Binary power. Not binary power. Binary power. Exponential by square. You know what I mean? You know what I mean? So essentially how that thing works, right? How that thing works, bpol. You have x and you have n, right? If n, I think equals 0, right? You return 1, right? If n divisible by 2, if n is divisible by 2, you return essentially x. Well, yeah, you have to save this thing to intermediate variable. Bpol x n divided by 2, like this. And then you return y. Right. Otherwise, you can... which person? Who should we ban? Who should we ban? To tell the name of the person, ban. Okay. Bpol -1. We can try something like this. We can try something like this. Why do you do that, STDRDK? Do you hate me that much? Why do you hate me so much? I didn't hate you personally. Holy fuck. So, and now I have an idea in my head that I don't need to binary power, and now I cannot discover that solution myself. Holy shit. Why, like... Now I'm sad. Like, you really disappointed me. Seriously. You really fucking disappointed me. Well, I'm sorry, I'm not as smart as you, so sometimes such things are not obvious for me. Yeah, so, like saying an obvious thing sometimes is actually spoiling. Okay. All right. It's not interesting anymore. It's not interesting anymore. Oh shit. Okay, I'm gonna go pee. Oh, for fuck's sake. spoiled the entire fun. Holy fuck. I hope you feel good about yourself. Alright, let's make a small break. Right, have fun. Yeah, you're surprised that I'm actually dumb. Yeah, very funny. Anyway, go away. So, essentially the idea is just to merge, transform, and crack loop together. That's the whole idea. And now I'm not even interested in implementing that because it's too fucking obvious. Okay, so subject number, loop size, and yeah, I'll need to think how we can do that. The problem is that I need to re-implement that from scratch again to properly understand. Right, so we already have that. Yeah. So an Rex should contain that public key. Rex should contain that public key. So I'm gonna start a new function. Crack loop size 2. So this is going to be that, and then we're going to have our CX 2020. So the thing about assembly is like it's really scary to touch any existing functions, so this is why I'm doing it like that. So we're gonna only, so what's that? So this is going to be the loop size. It's going to be the loop size. GMP begin, so this is going to be that. But RSI unfortunately is a public key. I'm so not motivated to do that. It's just, I know what I need to do, I'm just not motivated to do that because somebody fucking spoiled all the fun for me. Alright. And we need to maintain this shit, right? So RSI is a public key, and maybe this is going to be the RDX. Move RDX. It's actually too much, right? Because the algorithm is going to be completely different. So this one is, yeah, we already have this documented. So this is going to be our X, right? This is going to be our X, and essentially, yeah. But the cool thing about transform being separate is that I can use racks for multiplication, and all of the separations, it just works naturally. It's just so fucking good. But maybe we can accept the initial value here. I think that's what we can do here. So here's the loop size, a subject number, and the state from which we have to continue. You know what I mean? The state from which we can continue. No. So instead of transform getting a loop size, we can have one single transform step, which accepts the subject number, right? The subject number. Yeah, the subject number. Actually, the state, right? The state. But since everyone accepts subject number as RDI, we can do it like this. And the state, right? And the current state is just a single step here. And the result is going to be in Rax next state. Something like this. And this is what we're going to have here. And, okay. So subject number and shit. So we move RSI to Rax. Right, we move RSI to Rex, then we have our RCX 2020 1227 2029, okay. Then I need to multiply by RDI, then I take the this thing 0, then divide by RCX, and move Rex RDX. There we go. So this is the single transform step. This is a single transform step, and maybe now I can try to crack. Hopefully this is a single transform step, right? So subject number and the current state, and we can start with 1. We can start with 1. So we move that thing. So now we have RCX. We multiply by RDI, by subject number, initialize the remainder, divide by RCX, and we take the remainder and assign it to Rex, and this is our final thing. This is the transform step. Cool. Essentially in a crack loop, what we have to do, we have to keep doing this thing. So here's the transform. And we need a loop size, right? We essentially need a loop size. We have a subject number, we have a public key, and we also need a place where we're going to maintain the state. So we can try to maintain the state somewhere in RBX. So this is going to be our state where we maintain. Right, so this is going to be our state. So subject number, public key, and this is a loop size. So we also can push RBX, I suppose. We save all of these important things. Then I want to make a single transform step. And again, a single transform step takes what? It expects subject number in RDI, and state in RSI, but state is located in RBX, right? State is located in RBX. And we call a transform step. So Rex now contains the next state. which is a public key, right? And then we restore these things as they were. We compare the current state with the expected public state, and if it is, we just return that. And by the way, I think, well, I mean, that's probably okay. So do we need to save bx? I'm not sure if we need to save bx, because we're just gonna assign it to RSI. We're gonna just assign it to RSI. Okay, small break. Small break. Okay, we save all of these things. We restore RSI RDI. Maybe also pop RBX. Yes, pop RBX. Cool, cool, cool. We just restore them as usual. Then Rex. We just compare them. Pop Rex, increment Rex. But what's funny is that I need to move. So after that, thank you, Sibani. Thank you, thank you, thank you. I need to start over. Rex RBX. Okay, it's a current state. I save everything I want. So RDI already contains subject number, and RBX contains the current state. In Rex, we're gonna have the next state, and the next state could be one of these things. We compare it to our side. If it's not that, I'm moving Rex to RBX. So this is the next state, and then I pop Rex and increment it. Okay, makes sense. Do we really need to push and pop RBX? Do we really need to do that? I feel like it's kind of redundant, but I still do that just in case. Okay, so let me compile it. It does compile. And I'm gonna comment out these things. Okay, comment it out. Let's test on the sample. Break on start. Layout, assembly. Mm-hmm. 8. This is not what I wanted. This is not what I wanted, I said. Okay, one more time. I'm gonna comment it out like this. I want to crack a loop of both of them, just to confirm. Door public key. One more time. Break, start, run, layout, assembly, regs. 8, 11. They work. They in fact work. And so the encryption can be broken as well. Similarly, break start, layout assembly, regs. Cool. So it's 8, and the encryption key is exactly what we see in the sample. So that should be okay. Hopefully I didn't make any fucky. Cool. So this is the final sample. So break start, run, layout, layout asm, layout regs. So we crack that, transform that. This should be the final thing. Is this the final thing? Thank you to STD Error DK for ruining all of the fun. Thank you so much. I really appreciate it. Let's make a cup of tea. Let's make a cup of tea. Does anyone have any questions? Maybe you guys want to talk about something before we go into the part 2. Any plans for New Year? I don't have any plans, to be fair. How was your Christmas? We don't celebrate Christmas in Russia. But I mean, we don't celebrate the Catholic Christmas, which is on 25th December. We celebrate the Orthodox one on January 7th. And we don't even celebrate it as much as, for example, Catholic celebrates their Christmas. God cooler. Really? No. How is that a God cooler? This is not a God cooler. First of all, I got like I got derailed with the idea of re-implementing like the whole libc. This is first of all, this is not God coder move. Second of all, I give up on that idea. Then I paid too much attention to chat and got spoiled the solution. This is not God coder, seriously. This is not God coder move. Unfortunately, I'm a disgrace to the whole software development industry. Russians put way more accent on the New Year night than the Christmas anyway. Yeah, I think it maybe it comes from the Soviet times, because in Soviet times, like, we lived under like pretty heavy atheism, so there wasn't. Thank you so much, Carrot91, for subscription. Thank you. So we were celebrating the New Year, which was, it's still kind of a religious holiday if you think about it in some sense, but it's like, you know, pretty acceptable under the environment we lived in. Part 2, yeah, we're gonna do part 2 after I make a cup of tea. After I make a cup of tea, we're gonna make a part 2. So I'm gonna go to the kitchen and quickly boil up some water. Okay. Let's take a look at the part 2 while the water is boiling. The light turns green and the door unlocks. As you collapse onto the bed in your room, your pager goes off. It's an emergency. The elf calling you explains. The soft serve machine. Oh, is that a... Oh, I didn't know that. Okay, cool. In the cafeteria on sub-basement 7 just failed, and you're the only one that knows how to fix it. We've already dispatched reindeer to your location to pick you up. You hear the sound of hooves landing on your balcony. The reindeer carefully explores the contents of your room while you figure out how you're going to pay the 50 stars you owe the resort before you leave. Noticing that you look concerned, the reindeer wanders over to you. You see that it's carrying a small pouch. Sorry for the trouble. A note in the pouch reads, sitting at the bottom of the pouch is a gold coin. Okay. Looks like you only paid. You only need, after all. Okay, pay the deposit. Okay. As you fix the software machine, Santa offers you a ride in his sleigh. Maybe the resort has a chimney you can use. Congratulations, you finished every... Wait, where's the second part? You finished every puzzle in Advent of Code. I hope you had as much fun as them and making them. The fuck? There is no part 2? I was hoping to redeem my status of a god coder. First of all, somebody stole my status of a god coder, right? Somebody in the chat. And now I don't even have an opportunity to... Holy fuck, I'm so disappointed. It is what it is, and it isn't what it isn't. Is it not? I think it is. The missile knows where it is, because it knows where it isn't. By calculating the deviation... Holy shit, what the fuck is this? Oh, wait. This shit moves. Holy fuck. So it indicates how the storm was going through, I suppose. Right. Yeah, that's very interesting. There is no part 2. This is so strange. Like, what? Was it like that in previous years, by the way? Did we have like a part 2 for 25th one in all of the previous years? Yes. Well, yes, what? It's like this every year. 49 problems only. Huh, that's really strange. Okay, so, I mean, if it's like, this is me for like participating in all of that for the first time. So I don't really know. Okay, what I'm thinking is we need to like somehow properly document all of this shit. So if we're gonna hard code this stuff, right, we might as well implement an algorithm that prints these values properly. You know what I mean? We can try to implement I to A, right, I to A into the buffer. So here we're gonna have like a section BSS, right? So this is gonna be section BSS, and this is gonna be like a buffer. Thank you for the content so far. I really enjoyed it. I'm really glad that you enjoyed it, but unfortunately, I'm not that good at this shit, right? I'm not that good at this shit, so I always need to rely on the help of others. So I'm sorry. This is why I'm unemployed, by the way. This is why I'm unemployed. If I could solve it by myself, maybe I would have a job as a humble PHP web developer or something, but I don't even have even that. So I think my tea is ready, so I'm gonna go to the kitchen and you know, the usual. All right, so this is gonna be like a bonus extra content. We're gonna implement A to I, and yeah. Shazawak, hello, what's up, Shazawak? How are you doing? Really glad to see you. Bonus meme. Yes. Bonus meme. Alrighty. I feel like today is Sunday, but it's actually Saturday. That's so PogChamp. Yeah, it's a nice surprise. Okay, so we're gonna have a bunch of bytes, and we're gonna allocate like 256 bytes here. Maybe we're also gonna have like a buffer size. This one is a buffer capacity, right? So let's actually introduce buffer capacity. So this one is going to be resq1. Okay, so define buffer capacity. It's going to be 256. Cool. Sorry. So we have transform. We don't really need to transform at all, right? So this particular transform is not needed. So we only need to crack loop size and transform step. So and that should be okay. That should be definitely okay. Right. So let's quickly introduce A to I. Right. A to I. What we're gonna accept here, we're gonna accept RDI number, and what? We're gonna test RDI, I suppose, like this, and if it's equal to 0, we're gonna jump to the end, and end is located somewhere here. So this is gonna be the begin. I think this is how we're gonna roll that. So begin and end. Cool. Here, wait, don't you need to transform for the second step? Oh shit. Okay, let's go back. Thank you. Okay. Thank you so much. Assembly is too much for me. Same. It's really hard to program in it. I think my problem with assembly is that there's not that many abstraction mechanisms in it. There's not that many abstraction mechanisms. And I'm not sure if I can easily explain what I mean here, but I want a language which looks for which assembly is a subset. And then I can directly program an assembly, but then I can write compile time macros and transformations that let me abstract away from that assembly higher in a level until I program in C, and then maybe like not C. No. It's not that. I'm not sure how to explain that. So basically, I want assembly with a very powerful macro system, and not this like C-level shit, right? Not this, right? I want, you know, a thing that is assembly, but I also have macros, and I also have very powerful type system, right? So I can start by writing in assembly for a very specific platform, and then rise the level of abstraction until I don't see assembly anymore, and then I can take that low level layer and abstract it away and replace it for different platforms myself. And this is a single language. This is the kind of language I want, a single language that allows me to do these kind of things. And that language doesn't really exist. I think the closest thing I was thinking of is Jai, right? And I remember John was planning to add inline assemblies, and I remember asking him in his chat whether these inline assemblies will be available at meta execution. So would you be able to basically in the meta program take this assembly, transform it, and maybe even generate it? So, and he said that he doesn't see any problems with that, so it's gonna happen automatically. And if Jai will ever have inline assembly, it's gonna be really close to what I want, but not necessarily. So yeah, I want an assembly with a very powerful compile time mechanism, something like that. The page out of Jonathan, he doesn't have any book. Okay, so I think my tea is ready. What will Jai be used for? It was planned for games, but to be fair, games are just software, so general languages are made with something in mind. True. So you want assembly with a powerful compile time feature? Yes. Not whatever NASM has. This is like a C preprocessor level shit that I don't really care about. I want like a proper Turing complete language at compile time in assembly. was thinking about Lisp-like language that will be used for system programming, and as you know, Lisp macros are poggers. Yeah, it's cool, but I'm not a big fan of S expressions. That's the problem. I rather prefer M expressions that look like this, right? So I'd rather prefer this kind of expressions, if you know what I mean, right? Like instead of S expressions. I find them a little bit more readable, and I have a lot of experience in Lisp, so it's not like my opinion is based on the lack of knowledge about Lisp. I use Emacs for 10 plus years, and I wrote pretty complex extensions in Emacs Lisp. I programmed in Scheme and Common Lisp. I haven't programmed for quite some time, but anyway. And I also implemented my own Lisp. And yet, I'm not a big fan of S expressions. I don't really like them. I don't think they're that readable. So I'm telling you all of that just for the context, right? So just for the context, because every time I say that I don't like S expressions, people just tell me, "Oh, you just didn't program in Lisp like for a long time." I did Lisp for quite some time, and I still don't like them. So yeah, I think it's important for the context. So for instance, you're fine with the appearance of assembly, so there's not that much of a desire for abstraction, but rather than you want to have something similar. I cannot comprehend your sentence, I'm sorry. How many times has Zosin already crashed the system with ASM? 0. I'm not programming in DOS, I'm programming in Linux. It's kind of difficult to crash Linux with assembly. Come on. What year is it? I mean, if I were using Temple OS... Oh shit! God fucking damn it. Advent of Code challenge. Solve all of the problems in Holy C being inside of Temple OS. Holy shit. That's a cool challenge. Oh my god. Yes, that's what I want. Ah! Yeah, that's the content. Yeah. The whole like 25 days. Whole 25 days in Temple OS. Only inside of Temple OS. Yes, I wanna do that. I wanna do that. It's so fucking awesome. Hell yeah. Yeah. So by the way, after this Advent of Code, I do plan to continue solving other Advent of Code years, because I kind of like that, and we can do that challenge for like 2015, for example. I already solved one part of 2015 somehow. Will you do AOC? No, I'm gonna do other years. I never really participated in other years, as you can see. So this is me actually participating in Advent of Code for the first time. So we have a lot of content to go through. So yeah. Okay, so we need to implement A2A, right? By the way, I need to make a small break, chat. 2 minutes. I need to Google how to implement A2A. 2 minutes first. Wait a second. Alright, let's make a small break and you guys have fun. What's up, Epic assemblers? How do you call people who program in assembly? Boomers. I'm sorry. Let's implement A to I. No, I to A. Avengers, because they assemble, yeah. Okay, so what we're gonna accept here, I think I kind of look boomers there. So this is gonna be just a number. And we're not gonna return anything because we're gonna write directly to the buffer. That's what we're gonna do. We're gonna write directly to the buffer. What's up, JLPNSD? Do you think you can do this? I'm not sure if I can do that, but if you believe in me, maybe I'll be able to. By the way, I'm streaming for 4:20. Yes, 4 hours, 20 minutes. Nice, very cool number. Yes. RDI. So we're gonna begin here, and we're gonna test RDI, right? We have 90 raiders from Pilata stream. Holy fuck! Welcome. Good fucking morning, pilots. How's it going? We're programming an assembly. How about that? Bet you didn't expect that. Yeah, so we're solving, well, we already solved it, but we were solving the last problem of Advent of Code in x86-64 assembly, the dialect NASM, using Linux syscalls. And we successfully did that, so it was not that difficult actually, you just implement simple algorithms. Thank you, Scott Dev, for gifting a sub to Pilata. Oh my god! Congratulations, Pilata. You can now use the emote with your favorite language. JavaScript, yes, Sodium.js. Yeah. Anyways, yeah, it wasn't that difficult, but I'm finishing it off. So the thing about this is that I couldn't properly print the result on the console. So the way I did it, I implemented the algorithm in assembly, then I opened this program in a debugger, I broke at the start, and I run the program. Right. So I stepped through the function calls, and here is my solution. So my solution is located in Rex register of my CPU. So I extracted the solution from the register of my CPU, copy-pasted it to Advent of Code website, and it was correct. So this was my output interface. So yeah, it was kind of a cheating, but I mean, I was too lazy to implement like a proper output, so it was just easier to grab it from the debugger. And what I'm doing right now, I'm implementing like a proper output. Since I'm not using libc, by the way, this is like a pure assembly. We don't even depend on any runtime. We only call Linux syscalls. What I'm implementing, I'm just implemented I to A, which takes a number and converts it to a string, and then we will pass that string to write syscall of Linux, and it will print it on the screen. So yeah, so I already solved the problem, but I'm just finishing it off, making it like proper solution. So that's what we're doing. All right. So we're following Linux x64 call convention, where you pass the first integer argument in RDI. As far as I know, the convention looks like this: RDI, RSI, RDX, R10, R8, R9. Yeah. So what's cool is that in 64-bit Linux, you don't use stack to pass arguments unless you ran out of these registers. So first 6 arguments go to these registers, the 7th argument goes to the stack. And this is not necessarily true, this is only for integers. If you also have like 6 floating point registers for the arguments, you can basically put on the registers up to 12 arguments without using stack. So yeah, it's like 64-bit call convention. Anyway, it's not a Linux call. It's system V. I'm sorry. I'm stupid. Okay, so we're testing whether it's a 0 or not, and if it is 0, I'm jumping to the end, and here's the end. So I'm just trying to organize the loop. We don't have while loops or any shit like that. So yeah. Now, I need to take RDI and divide it by 10. So I'm gonna move RDI to rex. So it's in a rex, and I need to divide it by 10. So to divide by 10, I need to put 10 to some other register, for example, RBX, and after that I will be able to do something like this. Right, so what that does, it takes rex and divides by RBX, and adds the result of the division to rex, back to rex, and the remainder to RDX. So we have RDX, we have remainder in the RDX, and that's the thing we need to convert to a character. We need to convert to a character. So since RDX is 8 bytes, we need to access only 1 byte of it, and it's going to be located in DL. I think it's going to be located in DL, but I don't think it's that it matters that much. So hello, what? Hello, is everything okay? Anyways, so the next thing we need to do, I'm gonna take the remainder and I'm gonna add 0 like this. I'm gonna add 0 like this, and RDX, actually not RDX but DL specifically, contains the character. It contains the character. And we need to add that character to the buffer. We need to add it to the buffer. So the buffer is located in a global memory. So here's the buffer, and we also have buffer size. So I'm thinking that I'm going to initialize buffer size with 0. So I'm going to use this variable to keep track of the size. I don't understand shit what you're talking about, but okay. Believe it or not, same. I have no idea what I'm talking about either. So now I need to keep track of the pointer somewhere. Let me see. So we can put pointer to RSI, and it's gonna be just a buffer. You're a hacker. I never hacked anything in my life, to be fair, except I remember I was checking out CrackMe on stream, and essentially it's a pretty cool website that I found through Life Overflow. If you don't know who's Life Overflow, he's a pretty cool hacker. He is making like InfoSec videos on YouTube. He's really cool, really recommend it. And this is a very interesting website. So essentially you get binaries, you get like Linux binaries and stuff, and what you essentially have to do, you have to take that binary and generate a CrackMe for this binary by analyzing its code, its binary code and stuff like that. So basically it usually accepts like some sort of a key, and you need to go through this algorithm and implement generator of keys for that thing or something like that. Oh, and I basically took the easiest one on this website, and I just used GDB or something and cracked it. This is the only thing I did so far, and I didn't do anything super sophisticated. So I wouldn't call myself a hacker, but yeah, I guess, I don't know. A collection of crackness. Yeah, Tony's programmer brain doesn't talk to the rest of the brain, just like a real worker in a company. Yeah, I guess that's how it works. Okay, so we have a character here, and in RSI we have a pointer to the buffer, and I think I'm gonna just move that character to here, but I'm gonna actually move it like DL, right? DL. Before doing this, I also want to clean up RDX because yeah, it's gonna be like this. And after that, I need to increment RSI. I don't think it's gonna. Yeah, I also need to keep track of the size somewhere, right? If I try to compile this entire thing, I think it's gonna compile. Generally, it doesn't fucking compile. Okay, because if I go to comma, is it gonna? Yeah, it does compile. I can try to initialize buffer size with zero, and operation size is not specified. So that means I have to do something like quad. That's sick. Thank you. Keyword? Yeah, it's a keyword. Okay, it works. Okay, so it just doesn't know the size of the type I'm using here, so that's fine. And I wonder if I can now not only increment RSI, but oh, wait, you don't really need that. You don't fucking need that, because then you can just do the following thing. You can move Rex RSI and subtract the buffer from it. Yeah, and that's gonna be your size. That's gonna be literally your size. That's super cool. You don't even need that. So essentially, you just take the pointer to the beginning of the buffer, you move the characters, and you still know the beginning of the buffer. So then you take the end of the buffer, subtract the begin, and you get the size. So you don't need any of this shit. Cool. So that's kind of useless at all. But to be fair, maybe because we use Rex for the other stuff. Okay. We use Rex for the other stuff, but now this entire thing is actually reversed. Believe it or not, this entire thing is actually reversed. And what I'm thinking, what if we start filling it up in a reversed order? What if we start filling it up in reversed order? How can we do that? So we can take this thing buffer end. So this is where we have a buffer end. So this is buffer begin and this is buffer end. And what I'm thinking is that we can start from the buffer end. So this is the pointer, but actually buffer end -1. I'm not sure if it's gonna. I think it's gonna work. I think it's gonna compile at this time. And here, instead of incrementing RSI, we're going to be decrementing RSI. You see what I do here? We're decrementing RSI. And then what we're going to return, we're going to just return the beginning of that buffer. So we don't even need to reverse anything. Instead of reversing, we're just filling up the buffer in a reversed order. That's a fucking 5-head move. Holy shit. I'm on a roll. Okay, and our Rex returns that. And then we can just take Rex and subtract the buffer end, and it will give us the size as well. That's actually super fucking cool. Holy shit. Okay, so Rex here contains the final solution. So we move Rex to RSI, 03 like. Maybe, I don't know what 03 actually does, but maybe it is 03 like. So in RDI, we have to actually move it to RDI. Yeah, we move it to RDI, and then we have to call I to A. So we call I to A, and Rex contains the beginning of the buffer. It contains the beginning of the buffer. Fastest running solution in OS, not really. Okay. So I now need to make a syscall. Okay, Linux x64 syscalls. So here's the syscall table. So we're not using any libc shit. We're interacting with the operating system directly. We're interacting directly. So the buffer begins here. So it's move RSI Rex. So Rex contains the beginning of the buffer, I think. Not really, actually. Because after, yeah, we decrement RSI, we're pointing at non-existing thing. We're pointing at non-existing thing. That probably means we'll need to decrement Rex. Yeah, we'll probably need to decrement Rex. Wait. Increment Rex. See what I mean here? Increment Rex. So this is the beginning of the buffer. All right. RDX is gonna be RSI, but we're gonna also subtract buffer end the other way around. Buffer end, subtract RSI. Yes, that gives us the size. So we initialized the buffer and the size of the buffer. Now for the RDI should contain the file to which we're writing everything. So it's going to be std out. We're writing to std out, and the syscall itself has to be sys write. It has to be sys write. Cool. And then we are performing the syscall. There we go. And after that, we perform the exit syscall to exit the program, and yada yada yada. Okay. Is it gonna compile? Is it gonna compile? It does compile. So the next question, is it gonna print anything? It's not gonna really print anything unless we also... I have a divine intellect idea. What if at the end here, what if at the end, somewhere here, we're gonna have something like DB10? It's not gonna work in BSS section, I know that. It's not gonna work in BSS section. But maybe we're gonna put that into the data section, why not? So we're gonna have 10 at the end. Whatever. So let's actually put it like that. So it's basically not gonna print a new line, but it printed 5. I fucked it up. Okay, nice. Fucked it up. So I wonder what exactly happened. So it's that RSI. Maybe I should have actually just filled it up from 0 and, you know, reversed it afterwards. Maybe that's what I should have done. Oh, I know what I fucked up. So RDI. Yeah, I see. So we increment RSI, but also I need to move RDI. Yeah, I never moved the RDI. Yeah. Also jump begin. Don't I have jump begin? Yeah, I don't have jump begin. And also what? I also need to update move RDI Rex. Actually something like this. After I divided everything, this is a new RDI, right? This is a new RDI. Wait. What the fuck am I modifying? Why am I modifying transform? What the fuck? Holy shit. What the fuck am I doing? I was modifying the wrong thing. Holy fuck. Okay. And I'm thinking, what the fuck is going on? So transform step, whatever. Emacs again. No, it's just me. I'm just literally tired. Okay, so RBX 10. So we definitely need to GMP begin here. RDI contains the number. Okay, so then we put it to our side, decrement it, and then we also, after we move this entire thing, I need to move our racks back like this. Then gonna compile, attempt to initialize memory. Yeah, it doesn't have to be like that. Okay, and if we take a look at what happened here, there we go. So this is the solution. It actually worked. It actually prints the solution. And our solution is actually this, yes, 711945. Yeah, and this is exactly what it printed, and we printed that in assembly. The only problem here is that it doesn't print the new line, right? It doesn't print the new line, but we can also do some bullshit like this. NL, right? NL is gonna be like 10, and after you printed that, we can do another thing. So we're gonna move RDI STD out, move RSA. The buffer is going to be NL, move RDX1, move Rex sys right, and then just do syscall. So we can always do this kind of bullshit. Parser instruction, but it has to be DB, I think. It has to be just DB, and if you run it, it has a new line. There we go. So now it not only calculates the solution in the memory, it also is capable of properly printing it. So it's also capable of properly printing it. And we don't have to extract that solution from the debugger anymore. It will just print your solution, which is kind of cool. And this is exactly what I was going for. Cool. I'm super happy. Okay. We don't need this shit. We can just remove that. All right. And the time has come to commit all of that. So we probably don't need that. So time, we can take a look at time, sure. Is it fast enough? I don't think so. Probably. Okay. Final solution. We can push that right into the ribbon. But before we go, we need to document everything. O3 it. Can you even O3? Does NASM even have O3? I'm not sure. Oh, you can optimize. Okay, I didn't know you can optimize in NASM. All right. Yeah, come on. All right. O3. I need to do -b. All right, so it's O3, and does it run? It doesn't make it faster, to be fair. Yeah, the optimization was choosing the instruction encoding. It doesn't really improve that much, to be fair. Yeah, the same shit. Yeah, it's probably like just something that is faster to decode for the CPU. All right. So let's add the documentation for the ASM solution, right? Let's put documentation. So it's gonna be readme md, and it's gonna be, oh my god, this is not what I wanted. Day 25, not 24, 25. So this is the day 25 solution in assembly. And is there any official website of assembly? Assembly language. Cool. I think this is going to be the official, assembly. All right. Tested on. Tested on. And I'm gonna just put the version of the NASM. So what's the version of the NASM? Version, that one. Yeah, NASM version, this. We also use LD, and I'm not sure if... well, we can put LD here as well. Why not? Because we use it as well here. So tested on expected result. Console, and what we expect here is essentially this. This is the expected result. Quick start. All right, install Nasm. So where can I get the Nasm? Here's the Nasm. It's already scarfed quick start instructions, but it's the best I can do probably. Install Nasm and make sure Nasm and LD are available in path, and then just make. So if I just do make, it doesn't have. Oh yeah. So we have to update the make as well. So we're gonna remove all the input shit here. So if we just do make, it automatically does the thing for you. It automatically does this thing for you. Document the solution. There we go. I'm gonna push that right into the repo, and you can find all of the solutions right here. Chat, look at that. We have the final collection. 25 different languages. Look at that. We solved all of the problems, and for each individual problem we used different language, and this is the full solution. Even assembly, we use even assembly. Doesn't that deserve a sub? No, whatever. I'm just joking. So yeah, we fucking did it. We fucking did it. It's pretty cool. It's pretty fucking cool. You know what? I think the time has come to show off even more, and I'm gonna do the following pro move. I'm gonna make a screenshot and just... Holy shit, anonymous user. Thank you so much for gifting 25 tier 1 subs. Thank you. And everyone who got the sub, well, welcome to our epic 25 languages club. About that, yes, we use 25 different languages. And to be fair, I know none of them. You may think that I know 25 different languages, but this is not true. I know none of them, and I just copy-pasted, code from Stack Overflow primarily. So I was just googling how to do that thing in this language, and I was just copy-pasting that thing there. And by the way, you can even find all of the screencasts for all of the solutions in the solutions themselves. If you go into the solution, there is a link here, and you can even watch me solving that specific problem in that specific language, like in a recording. So we recorded and documented everything, fucking everything, and it's gonna be there. And it's gonna be there. Okay, so I wanted to do the final thing before finishing it off. Scrot -s, and like this. I'm just gonna wait a little bit. Okay, so now I have the screenshot, and I'm gonna put the screenshot into the README. Alright, so here it is. And I'm gonna copy paste it here. Thumbnail. I'm gonna go with thumbnail. Why not? So, and it's sort of like to show that, well, it would be also nice to include my my profile. So it's me, Rexim. Let's actually quickly do that. We need to include the storm. We need to include it. Okay, so and I'm gonna go here, and I'm gonna copy paste it here. It's actually went here. Here it is, and thumbnail. Let's delete that. Thumbnail, and I'm gonna put it here. All right. thumbnail. Cool. So, and I'm gonna just do it like that. Add thumbnail. I'm gonna push that right into the repo. Let's see if it's gonna look okay. Yep. Yeah. There we go. So this is sort of like an indication that we solved all of them, and these are the full solutions. And we have a solution for each individual problem in a different language. In a different language, how about that? Tell me, does it have your favorite language? Does it have your favorite language? We tried everything. Rust, Haskell, Java, D, C++, Python, Go, JavaScript, OCaml, C, NIM, Perl, C#, PHP, Pascal, Ruby, Scala, Kotlin, Lua, Julia, Racket, Groovy, Dart, Ada, Asm. Well, no Fortran, yeah. Yeah, unfortunately we didn't have enough problems to cover all of the languages that I wanted to cover. We still haven't tried Erlang, Elixir, Fortran, Forth, but it is what it is. We didn't try a lot of languages. My favorite language is Haskell. We did it in Haskell, so here it is. Here's Haskell. Which was your favorite puzzle? I don't remember. I forgot all of the puzzles. This challenge damaged my brain so much I don't remember a single puzzle. I don't remember what was the 25th puzzle. Like I just solved it and instantly forgot. There's also 2021 maybe, yeah. Day 25 part 2 was my favorite puzzle. Yes, I see. Anyways, today was a pretty interesting stream, I would say. It was a pretty interesting stream. But unfortunately, it is time for me to go. Thanks everyone who's watching right now. I really appreciate it. Thank you for the subscriptions. Thank you, Anonymous, for gifting me 25 subscriptions. So I finally will be able to pay rent this month, because I was a little bit worried that I won't be able to because the income today was a little bit lower. But you saved the month. You saved the month. Thank you. Thank you so much. Yeah. Thank you everyone for watching, and I see you all tomorrow. Tomorrow, unfortunately, we're gonna do a game development in C++ without any advent of code stuff. Finally going back to our regular schedule. But I kind of liked solving competitive programming problems. So maybe we're gonna dedicate one of the weekdays to solving Advent of Code, the previous years of Advent of Code, and maybe some other competitive programming problems like Codeforces, AdCoder, or something like that. We'll see, we'll see. So check out our schedule. Holy shit! The Soul Seeker. Another 10 subs. Thank you. You didn't have to. 25 was enough, but thank you. I really appreciate it. Thank you so much for gifting 10 subs, and everyone who got the sub. Welcome to our epic 25 languages club. I'm sorry. So yeah, now we are officially 25 languages club. How about that? Isn't that epic? Please tell me that it feels good to be part of the 25 languages club. Please tell me. 25 languages club. All right. Yeah, did I say the schedule? Yeah. Check out our schedule page for more information on different different projects we're working on. Also check out our VODs channel, where we upload all the recordings of our streams. This stream is going to be there, but tomorrow, by the way, on that channel you can find the full playlist for Advent of Code, because we upload everything there. And by the way, you can go to any solution, just click on that solution, and the link to the screencast is going to be there. So if you want to just watch me using a particular language for a particular problem, you can just go there and check it out. And also check out our Discord server for offline discussion with the community. We have a pretty cozy community. Welcome. And what can I say? I guess maybe we should raid somebody. I don't know, because we got raided by Lada, so I think it only makes sense to raid somebody as well. So, is anyone streaming anything interesting today on the science and technology section? Gamoza, is Gamoza streaming? Is Gamoza streaming? Yes, if Gamoza is streaming, we're gonna raid him because he raided us last time and I wanna raid him back. That's for sure. Okay, so I can see that he's streaming. Alright. So, wait a second, it's gonna be a raid. Gamoza. Alright. So, get ready for the raid, boys and girls. Get ready for the raid. And I see you all tomorrow. Love you.